Okay. Well, hello everyone. It's been a minute. I do want to say some cool things real quick. So first off, hello everybody. it's been like a week, just about. How's it going? How's everybody doing? Anything fun going on? I've been so last week I was preoccupied with work. So I ended up crashing at someone's place to make the commute a lot better, and I stuck there for the entire week. So that's what happened. That's why I had to, it's crunch time and tax season and pretty good stuff. So 𝖘𝖈𝖎𝖎𝖙𝖘 and Stucky, how's it going? Time is a flying. Yeah, it's already the 4th month of the year. Think about that. Well, I remember it was just like yesterday, it was New Year's, and then the second before that it was my graduation. So my university graduation, not the other one. So hi Terry, how's it going? Terrified Games from twitch.tv/terrifiedgames. How's it going, everybody? So yeah, I was preoccupied with just work stuff, getting the grind out, and while I was away, actually, quite a lot of fun stuff on my own end. So I was very much doing a lot of self-study, self-reflecting, just planning things in my head out. So, and the time away was kind of like good, because as much as I do like streaming, I very much wing it most of the time. You guys probably can tell. So now I have a better idea on what I want to do soon. And of course, stressing too much about it is bad. So I'm gonna worry about it less as it goes on. It's very good to just take a break and relax a lot. So let me go ahead and first off, big elephant in the room. Not long after I took my hiatus, I hope they're in the chat. I hope she's in here still. So let me see. We have an art piece, and I think someone here knows about it. You're not here, you left. I have to bring it up. It's a very, so when I left, not long after I had just left, in the server, Nepenthes over here, Nep, she ended up making an art piece where she's just bullying me, and at this point I'm like, you know what, sure, go ahead. So let me go ahead and pull it up real quick. If you guys have seen it, and then you've seen it, it's also on my Twitter, so if you guys have seen it there, then absolutely just take a look. But let me pull it up right now. So you want to explain the message of this piece? So I'm very concerned. I'm very curious. Let me find, not this. Well, nerd. Okay. So let me go ahead and show it off. I have it. Boy, I really organized my folders well. Okay, here we go. So she made an art piece, which absolutely looks fantastic, by the way. So I'll put it right in front of me. Yeah, so it's very cute. So it's her model versus and mine, just staring at each other. She's doing what's it called, a 𝖘𝖈𝖎𝖎𝖙𝖘? A 𝖘𝖈𝖎𝖎𝖙, right? Yeah, so she's picking on me. She's bullying on me. This is a 𝖘𝖈𝖎𝖎𝖙. Yeah, okay. It is absolutely lovely. I think it is very good. It's the first fan art that you. So here's what happened. Let me explain exactly how this whole process happened. Nep texts me in the middle of the night. She's like, "Hey, because we're talking about some stuff behind the scenes. But she hits me with this. She's like, "Hey, I'm gonna make an art real quick," and I'm like, I was doing some stuff, so I was preoccupied and already busy. So I was like, yeah, sure, okay. I'm curious about it. Then she sent me this, like the draft, the first draft. And then she's like, it's this, okay? It's basically me bullying you. I'm like, huh? And then I was like, okay, that's very, very, very sweet. But I have to go to bed. I have to work. So I told her very nicely, I'm like, I'm sorry, but I'm gonna go. It is time for me to, you know, it's EP time, nap time. I have to go to my job. So I went to bed. Next morning, I see this in my Discord. I see it on her Discord server. And then she posted it basically everywhere that everyone could see it. So that put me on the spot. I thought that was actually really hilarious and also kind of mean. So, yep, if you are still in here, I'm going to say it's great. Okay. It's very, very good, but I don't know what to I'm just flabbergasted, I guess. It was very, very good. So, thank you very much. I wonder if I can. So if you saw my Twitter too, she used her profile as she updated her profile to this image of her, and then I updated mine to be my face too. So yeah, very, very cute. And I do not know what to say. So thank you, Nep, very much for the art. It is delightful. It is. Yeah, I did. You should check it out. Literally the same day I think you did, because I saw it. I was like, it'd be really funny to just match that. So thank you so much. This is really, really cool. I might make this an emote or something. Maybe I can ask you if I can just get a version of this file. Looks really good. Look at the detail on that. Look, it's really, really sharp. It's really, really nice. Okay, all right. Okay, moving on. I'm gonna keep that in the corner real quick. Okay, next thing I want to come back and talk to you guys about. Let me see. So I was actually able to self-study this week. So one of the things that I end up learning about, I'm already planning a collab. I guess I should say, I'm gonna be collabing with someone soon, and specifically a math topic, Vtuber, and one of the topics we're gonna cover is something I did in physics. At least math-wise, I did the physics, the math of the physics a bit. So I was reviewing some stuff from my math methods textbook. So I suppose I can find the version of the math methods. Math methods. And reviewing some of that stuff, I remembered that, oh man, there was a lot that you have to cover in math methods just to even get started. So the very first page, I used the math methods Boaz book, 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. It's gonna be this one. So I guess I can duplicate this. I'm really prepared. Ah! Okay, well, that's the guy I was talking about. What's up, Gauss? How's it going? How's it going, buddy? Pal, buddy, chum, pal, friend, pal, buddy, old pal, guy, friend? How's it going? You were playing, I saw you for a second. You were playing that one game, weren't you? Personas 4 or something, right? What was it? I gotta play more games. Well, actually, that's another thing. I actually do have a game we can play today, so that's exciting. This is the book that I was talking about. Somnium files. That's right, or AI Somnium files, right? Were there any good jokes this time? So and then I guess let me talk about this real quick. Thank you. Yes, very good. So Gauss, actually, let me tell you this then. So I'm actually reviewing the math methods book that I have. I have the 3rd edition of this one, so exactly this. It's really good. It's a really, really dense book. Have you read this one? Or covered material from this book? I'm not sure what... So if you don't understand... If you don't know what math methods is, basically it's math techniques so that you can do really hard physics. And it's pretty notorious for being a dense... Like, it's really applied math. All of it basically is applied math. So... Not even a smidge. Covered in material in it, probably. Yeah. So, one of the things that I covered was, let's say... Oh, and thank you so much for the follow. Xenotime, hi. How's it going? My math message professor didn't follow a single book. Use the 𝖈𝖊𝖉𝖎𝖙𝖘. I'm gonna look that up. So this one was good because I covered this book by Boaz the entire time I was in university, up until Math Methods 3. Actually, let me tell you the order of operations. So I ended up taking Math Methods 1 first. Then there was an invitation from the math department to take the Math Methods for Physics 3. It was a graduate level class, and I took it because I was, cocky, and I was capable at that time. Sophomore year, I'm taking a graduate level class. Sure. So that's what I ended up taking, and that was completely different material-wise. It was basically theoretical physics, and we did not cover this book at all. So that was the class with the 4 assignments. One of them dropped for 3/4 of the weight of the class, for the grade. So I failed both midterms and one math class in uni. You had a tutor? Well, hopefully I'm gonna probably cover some stuff that anybody can learn. So you will be learning regardless. No, hopefully you'll learn something for sure. But then we went back to, so after Math Methods 3, I ended up taking Math Methods 2. So, and then in Math Methods 2, then we covered like Fourier series, different kinds of analysis and tricks like that. So this is a pretty good book. And more importantly, the material that I covered, one of the last things I covered was residues. And basically you take a real function and you extend it to the complex plane, find the singularities, solve for residues, and then extend it back to the project it back to the real space, and then you get an answer. So for wacky integrals that have like no convenient real solution, or don't have a very convenient solution, I still have the problem that I wrote in on my whiteboard. I have not erased it because it's out of the way, but that was one of the coolest things that I actually learned. It was that you can just extend functions into the complex space and then solve for stuff there, project them back, and then you get a real answer, which was pretty cool. I thought it was cool. And then this book actually covered it. So it was something to do with Kronecker delta, no, Stirling's, Lagrange's, no. Yeah, Hermite functions or something like that. Yeah, pretty good. Did you have to do a 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 integral? I don't think I did. I don't know what that is. Unless that was it. Let me look that up. What's a 𝖈𝖗𝖊𝖉𝖐 function? Don't worry about it. So if you're here for normal math stuff, like the more healthy, competent things today, we're gonna cover some stuff. And I have a game that's gonna be good. So 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. Yeah, it's about inverse Laplace transform, but you use residue theorem for it. Oh, okay. Here it is, 696 in the textbook. I wish I can pull up a... Yeah, okay, this is exactly what we did. A little later on, it says it looks like we're on 696. Okay, yeah. So, the integral, so from which function. I think that was probably what we had to do, because we had to create the that like horseshoe thing. Really cool stuff. So anyways, Gauss, I'm gonna try to look for some of this stuff again, and review so that we can talk about something cool with Laplace's, and then let's cover some history too. So we'll follow up with all that stuff. We'll definitely get things going. So don't you forget, don't you worry. So yeah. So not only this book am I covering again, I'm also covering my abstract algebra book. So let me see. My current abstract book is the Gaussian one. And actually, I think there is a PDF of it. So the Gaussian book is pretty good because it actually starts you off with group theory, and then you go into field theory. So let me save this real quick. And then swap this out. So the math methods is good, but that was all physics. The Gaussian book is really good. And it gives you little nuggets about like, I also have the 9th edition. I have this particular one. It's really good because usually what I've heard from abstract algebra classes, they start you off with fields and yeah, so basically fields and other sets. So then on top of that, this one also just starts you off in groups. So I think that groups made a lot of sense. Groups are easier to understand, the theorems are easier to prove, and then I ended up taking abstract 2, and we covered rings and fields following that. And it was really fun. It was probably one of my most favorite math proofs classes. So very, very fun stuff. So I was reviewing this book on my own just a bit, you know, so like generators, cycles and things like that, subgroups, and then I wanted to probably give an example specifically with like the Rubik's Cube, because I actually am curious about like the math that they use for it. There is a typo in this version. I discovered that there is a comma off when describing the number of permutations for a Rubik's Cube, and because of that, I genuinely don't know what it. I can look it up right now. How many combinations of a Rubik's Cube, how many permutations of a Rubik's Cube are of a 3x3 Rubik's Cube. So yeah, so there is a typo, and I noticed that, and I thought it was really funny. So there's at least 3. Yeah. I actually don't know how to solve a Rubik's Cube. I know the technique though, especially for bigger ones. So, and I've done it for bigger ones up until I make it a 3x3. The whole point of the trick with solving Rubik's Cubes is that you make a bigger Rubik's Cube become a 3x3 Rubik's Cube. And then after that, you make the 3x3 Rubik's Cube and solve it. And that's the only part that I cannot do. So, pretty neat stuff. That's what she said. Okay. So, what my favorite part about... Yeah, so I'm covering this book. It's really cool. How many permutations? Okay. If you're gonna head out, Net, have a good day, okay? Let's see. How many permutations of a Rubik's Cube are there? So approximately 43 quintillion. So 43 quintillion. That's, what is it? A billion? Yeah, 43 quintillion. So 43 followed by... Oh, that's a lot of zeros. Hold on. 1, 2, 9, 12, 15, 18. Okay, 43 followed by 18 zeros. So 43. I can type it out. Hold on. It is There we go. Approximately that many combinations. That is a lot. So, and I'm very curious how they got the actual number. Clearly, it must be a answer from a computer. But I want to know like what algorithm, what method they used, and probably just like the algorithm like analysis of it. Pretty cool. So without abstract algebra, you could not quite properly explain the number very well. So cool. Let me go ahead and also mention I do want to do some more videos for the YouTube channel and my just shorts in general. So what I'm probably gonna do is I'm gonna take some more time for myself because I'm quite tired from this week, but I'm also gonna use that time to edit some stuff, and I'm gonna try to cover from some things for my channels. So I'll edit some videos down. I'm gonna make some animations, and I actually am gonna do a bit of an animation today, because the first book from the 𝖈𝖊𝖎𝖆𝖕𝖎𝖙𝑘 actually had a really good starting section, and it had to do with geometric series actually, and I really liked how it described it and the physics explanation, the physics example, and you will not think of it. So pretty cool. I'm gonna probably work some more on animations and preparing videos. So if that's the case, I just need to focus on making the videos, editing, and everything like that. I have no idea how some people like have their turnover, and get that stuff going. I'm impressed because I try my best to manage my time, and even then I don't. Like today, I was supposed to be here at what did I schedule today to be? At 1 o'clock? Well, that didn't happen. So that's not good. And I think keen observers would also notice that last week I did promise a stream, and I was gonna cover the golden ratio and stuff like that, and I ended up not doing any of that, because I was just beat and I had to prepare for stuff. So yeah, I'll be on it. I will be on top of things. I will get working. I will get things going. You guys will see me more. I'm gonna grind, but I will do things in a timely manner and also prepare for collab material. So lots of things. I'm very excited. Very cool. And with that said, why don't we get started and play a game? So I have a game in mind. Who here has ever played the game Marble Marcher? Let me see if I can pull up a video about it because I really like the so it is a project once upon a time made by the one and only 𝖘𝖔𝖈𝖎𝖎𝖙𝖘, and in the game, you basically just march around a fractal. You know those marble games where you can move around and solve obstacles and just go off ramps and stuff like that? A really primitive physics game. Well, this one, the gimmick of it is that you get to experience a fractal. So what I really like about it is that it's just the cool generations, and I didn't think my computer could run it. I tried running it on my laptop, and it could not work. But because it's so compact, the game is actually really good at running nowadays on any system. So it is quite cool, quite good. So let me go ahead and transition to my gaming side. We'll see what I also have up right now. What weird things do I have? So, and I do have Blender ready for anything that I want to do in a minute. So that's good. Let me go ahead and pull up the theorem of the day. So we're gonna watch a video of the what 𝖘𝖔𝖈𝖎𝖙𝖚 has done. I hope that I don't get a copyright claim for it because I'm just covering what the material is exactly, and then we're gonna play it, specifically the community edition. So where is it at? Come on. Okay. Let me check my studio settings. And then, of course, we're going to cover the theorem of the day. Give me just a second. Okay, hold on. I'm very good at this. Okay, got it. All right, so what I want to do next is I have some feedback. What's going on here? We're going to ads in a minute, so let me go ahead and fix that real quick. I can hear myself, which is not good, so that's not good. Oh, I know why. Duh. Never mind. Okay. Let me go ahead and cover the theorem of the day, and we have a break in 40 seconds. So let's make it quick because this one I looked at and I don't think I understand. Oh, actually, this is a different one. Dang it. Okay. We'll see soon then. The 𝖈𝖗𝖉𝖎𝖕𝖎𝖙𝖘 theorem on a 𝖈𝖗𝖉𝖎𝖙𝖍 loop of any three elements which associate generate a group. This is a group theory. That was just what I was copying about abstract algebra stuff. Well, that's cool. Hold on. But what does it do? What does it mean? And these are quaternions and octernions. So So, if you guys are an ad, that's fine, because let me go ahead and figure out what this is. In a 𝖈𝖗𝖉𝖎𝖙𝖍 loop, any three elements which associate generate a group. Any three elements which associate. Oh, so any three that you can do in a different order. No, that's commutative. Let me just read this. With I, the imaginary constant whose square is -1, the set plus -1 plus -I form a group. The multiplication keeps you inside the set. It allows inverses. Example, I times -I is -I squared, which is also just 1. I to the -I is in fact just -I, and it is associative because you can do them in a different order. X times Z, and Y times Z, prioritize. And then it's the same as X times Z times X. Bleh, I can't read anything. Hi, Starry. Hope you didn't get bombarded by the ads. How's it going? I'm doing math stuff. Let's see. Okay, the bracketing can safely be forgotten. In 1843, a great Irish scientist, William Rowan Hamilton. You guys know Hamilton, right? He was a president or something. Discovered the quaternions. He also discovered quaternions. I is joined by mysterious companions, J and K, who multiply according to a circular diagram above the left. This one right here. If X and Y follow each other clockwise and around the circle, then X times Y is equals to plus the other quantity. If anti-clockwise, which is what you British people say, or Europeans, the product is negative. So IJ gets you K, KJ equals -I. Oh, that's how it's defined. They have always wanted to cover quaternions, but I didn't quite understand how it was phrasing itself. Oh. And quaternions are really good for especially rotation in 3D dimensions. So people use quaternions for it makes it so that you don't have gimbal lock in 3D programs and simulations and stuff. So that's cool. And again, that makes a group. And then Graves, the professor of the law of London, was inspired to try to go one better. Just 2 months later, he produced the octonions, whose multiplication table is given in the center and is constructed from a Fano plane. Fano plane? That's the diagram on the right. It only has 3 points in the center at any given, and we must imagine E goes to J, it goes to G. For example, circling back around to E. So we have the letters 1, I, J, K, E, F, G, and H. I do not know what octonions do. Does anybody know anything about octonions and maybe their applications? Because I can't see what they could be used for right now. I'm not familiar with them. I know quaternions are great, and actually 4D matrices are really good for 3D programs, believe it or not. But octonions, I would guess probably theoretical stuff. Let's see. But Hamilton spotted a snag. Octonion multiplication is not associative. Uh-oh. For example, IJ first times E is equal to KE. However, that becomes J and then H. But I times JE is equal to I times minus G, which is minus IG, which is equal to minus H. So it actually gets you the negatives of stuff. That is strange. The octonions have discovered independently by Cayley, and are sometimes called Cayley numbers. That's what those are. Independently called Cayley numbers. I remember Cayley stuff. Cayley was a mathematician who did stuff with... Actually, wait. I actually don't remember right now. Cayley table. Cayley's theorem. Hold on. Let me remember what his theorem was. Because it is group theory related. It states that every group is isomorphic to a subgroup of a symmetric group, meaning that any group can be represented as a group of permutations. Oh, that's the one. That's the permutation one. It's a really good one. I actually really did like that one the most. Permutations are probably the coolest thing because it ties back to combinatorics. It does not tie into statistics, which is great. So, 100 years later in Germany, Ruth Wolfgang, invented a deep connection between algebra and projective geometry via the idea of a loop. Exactly those arithmetics which fail to be groups just through being not associative. A Wolfgang loop is one in which any x, y, and z nearly associate. They obey 3 equivalent Wolfgang identities. Left, which is a pairing, x, y times x, then times z, is the same as x times y times x times z. So order does... And it's end associative, I think. Middle associative, or you can split them up. xy times zx is equal to x times yz times x. Interesting. And then right associative. Yeah, don't worry about it. I don't quite get this one either, but it looks like this is almost associated. So you could check these hold in the octonions and are a classic example of a Wolfgang loop. The quaternions hiding associativity inside our group thanks to Wolfgang's theorem. You can check too the corollary to Wolfgang's theorem. Any Wolfgang loop is dissociative. Any pair of elements whatsoever generates a group. Put y equals 1 in the left of a Wolfgang identity and apply the theorem to x, y, and z. For example, EF generates a group of order 8. Oh. With elements plus or minus 1, plus or minus I, plus or minus E, and plus or minus F. Interesting. And it played an indirect role in the classification of a finite simple groups. Richard Parker's 1985 construction of a Wolfgang loop of order 2 to the 13, so that's a big number, was used by John Conway to construct the monster of order 8 times 10 to the 53. What is the monster? Hold on. Is that just a number? The monster Conway. What? The monster group. Oh, shoot. Let's go ahead and read the article about that then. Fun little thing about Conway as well. You guys are probably familiar with Conway's Game of Life. So, I remember a chat member in our Discord was mentioning about how Conway was he made the idea on a whim, or whatever the case. He happened to just have make Game of Life, and when he did it, he was very like apathetic to the idea. So this Conway, the one who was like, you can generate things, and then when you press play, it automatically updates everything. Depending on some rules, right? So the rules are all this nonsense. I'm not gonna over iterate what Conway's thing's done, but people have done lots of things before. Hey, look, I got a thing. Look at it go. So he actually hated everybody asking him about the Game of Life for up until he died around 2020. So kind of a bummer. Conway, cool dude though, very cool dude. Bummer. His most famous thing is something that he did not like. So, you know, it's kind of like Smash Mouth with All Star or Abraham Lincoln and getting shot. You know, so pretty cool stuff. Yeah. Then let's take a look at Conway. Conway's look at him. Look at all cute like that. Yeah. Yeah. Finite groups, not theory, number theory, combinatorial game theory, and coding theory. Woo. He's like my dad. So, okay, the monster group. If it's got 8 times 10 to the 53, that is a huge number. So it is a friendly giant group. The Fixter Grace monster. A friendly giant, or simply the monster, is the largest sporadic simple group, and it has order this much, which means that it has this many things inside of it. I don't think Lincoln had an opinion on that. Well, Lincoln did a lot, which is cool. So I mean, it's probably a big deal that he died. So at the moment, it's probably very important. So I guess nowadays we talk about different things like, you know, the Emancipation Proclamation and all the other cool stuff that, you know, American history has to say. American history. You don't have an Emancipation Proclamation. So, I don't know. Okay. So, if it has order, this is a big number. And actually, it does break down the... Does it break down the methods it uses? 2 to the 48, 46, 3 to the 20, 5 to the 9, 7 to the 6, 11 to the 2, and so on and so on. Then these guys can be broken down, and then you can find this out. It is difficult to give a good construction definition of the monster because of its complexity. Oh, fair. Martin Gardner wrote a popular account of the monster group in his June 1980 mathematics game column in Scientific American. Okay. So, is there a way I can pull that article up then? That actually sounds kind of cool. So, let's learn about the monster, okay? Martin Gardner, the monster article. I am not sure of the legal copyright for doing this, but it's from the 80s, so I'm going to say it is A-OK. I will reject optional cookies, please. So, gimme. Oh, I have to sign in for it. Sign in to download the PDF issue. The issue PDF. I really want to read it. Give me a second. I think this will be cool to cover. Hold on. Let me look up something quick then. Let me prepare my sign-in stuff, and then I can get that going. Let me see. Do you guys want... I was in Jewel Tears. Jewel's chat the other minute. Do you guys want to have the fish doorbell for a second while I get this set up? So, who knows what the fish doorbell is? I think that's going to be fun for just a second while I get it prepared. let me go ahead and create an account. We're gonna watch the fish doorbell for a second. Not sure how it works. So if we see a fish on this side of the screen, then it's just swimming around, acting all fish-like, you know. And then what we do is that we can click this little doorbell, and what it does is if it lets a notification happen, and if you know the operators can see that there's a fish there, or I think we do it. It's an automated thing, and then the fish can pass through the dam. Wait, what was that? So like if we see a fish, then we can like knock the doorbell and the fish can go through the dam. And I'm not sure which specific dam this is. This is the okay, so there's like bleak, catfish, common roach, eels, freshwater breams, 𝖈𝖗𝖊𝖉𝖎𝖙𝖘, perches, pikes, pike perch, blah blah blah. This is for the 𝖈𝖗𝖊𝖉𝖎𝖙𝖘 in Utrecht. Or so for the fish could be going swimming upstream to lay their eggs. So that's cool. We're in the Netherlands. So let me go ahead and create an account, and I'm gonna want to read this article. This is gonna be cool. Oh. And I guess I could sign up for the science newsletter. Sure. Does it have two-factor identification? Are you kidding me? What a scam. Okay, this is where scientific articles and finding cool research papers becomes a problem. I need a squipsin. Okay. We'll make do. Let me find for something else then. Let me see if there's another way to access this article, unless it's genuinely impossible. It's from the 80s. Why does it need to be all under lock and key? Oh wait, I got it. Is this the thing? Oh, that's like page 20. Hold on. I want the full article. Read through your school or library. Okay. I'm trying to go back to school so that I can... Damn it. Okay. I hate being independent. Well, we can look about it later, okay? At least I tried. I was really curious about that. From the gist of it, though, it looks like that this is some sort of, like, a simple group. Let's talk about simple groups and stuff, okay? Maybe I can look about it in here. So Conway's chilling. We're over here. We're hanging out. Let me look for monster group. It's a sporadic simple group. Let's click this article. What is a sporadic group? In the mathematical classification of finite simple groups, which let's go ahead and look at finite simple groups. The classification of finite simple groups, popularly called the enormous theorem, is the result of group theory, stating that every finite symbol group is either cyclic or alternating, or depends on a broad infinite class of groups called Lie-type. It is one of 26 exceptions. Or else it is one of 26 exceptions called sporadic. The tits group is sometimes regarded as a sporadic group because it is not strictly a group of Lie-type. The tits group. In group theory, the tits group 2F4 named after Jacques Tit. Is it T? Jacques T is a finite simple order group, a finite simple group of order this much. Oh, that's not too big. 17,971,200. This is the only simple group that is a derivative of a group of Lie-type, and is not a group of Lie-type in any series from exceptional isomorphisms. It is sometimes considered a 27th sporadic group. Yeah. This is actually interesting to me. History and properties. So the tit group, guys. The Rie groups were constructed by Rie in 1961, who showed that they are simple if n is bigger than 1. The first member, 2F4, so this is the group set, and then you would have specifically 2 to the 1. If the first of the series is not simple, it was studied by Jacques Tit in 1964, who showed that it is almost simple. Its derived subgroup is 2F4 2' of index 2, and being a simple group is now called the Tits group. The group 2F4 is a group of Lie-type and has a BN pair. Okay, these are terms now that I am not very familiar with. I remember Lie algebras. I remember Lie groups. I do not know too much about the extent of abstract algebra. But these are cool, because now I'm actually just learning stuff. Hold on, does my book actually cover some of these things? Let me look farther ahead, because it got into... I see an article about Galois. I have a thing about abelian groups. Gardner. Hold on. Hold on. Sorry. Hold on. And I'm also sick, by the way. I'm, like, fried. I see, I literally just pulled up the right page on the book. And it cites the same thing, Mathematical Games by Scientific American in 1978. What? Maybe I could look at the Galilean exercises from the book. So what does this cover? Covers unique factorization of Zx, Einstein's criterion. I don't know those. Polynomial stuff. Okay, I don't know anything about that right now. Okay, not the same thing. Well, I guess not. This is like a book about abstract algebra and... Oh, wait. Finite symbol groups. We found the article. No. Pacific Journal of Mathematics. Not the same thing. Oh, no. There is a thing. There is a thing about the monster theorem. Okay. Okay, hold on. It's in the special topics section in the abstract algebra book. So let me pull that up real quick again, which book I'm referring to. It is page 404 of this thing. So let me find the book. I'm not talking about you anymore. Get out of here. I'm talking about this one. And actually, probably, can I pull up a PDF of it? Well, I'm not sure of the legality of it, and probably not of anything. You call this coding and this disgusting piece of gum I stepped on the side of the road and needs to be scraped off my shoe? This is coding. You can code group stuff. Don't you know? It's good stuff. Also, hello, 𝖘𝖔𝖈𝖎𝖎𝖙𝖘. How's it going? I am covering right now. I'm in a rabbit hole discovering stuff about the monster group. So, let's look back at the monster group real quick. The monster group looks like this. It is this many. It has order this much. This is a big number. Big numbers make us fun. Make things funny. It's yeah. It is. And I'm learning about what this particular group has to say about anything. Which, by the way, crazy first impression. So, I'm glad you have something nice to say about that stuff. But yeah, I am a math Vtuber. I cover a bunch of math material. Lots of things that aren't even, like, tangible. So, you know, I'm here to just vibe and learn about cool stuff. Maybe on archive. I could swear that I have a thing for it. Dang it. Well, okay. Let me just cover what the book says about this stuff. But simple groups. Let's go back to simple groups real quick. So every finite simple group is either cyclic or alternating. Maybe I can pull up an example of some group stuff. And for that, I'm gonna use some 𝖘𝖔𝖈𝖎𝖎𝖙𝖘 stuff. Hopefully it doesn't have anything sketchy. Oops. Create. It's thinking. Maybe I can to talk about permutation groups. Permutation groups are a good one real quick. Not these ones, because these are polynomial things. Oh, yeah, okay. Maybe I can use this for an example. So, let me pull up the critter real quick. So, if we're talking about a group, in general, okay? A group is something along the lines of, it's a set, it is a set with some special properties. So, the whole thing about it being an algebra means that you can do an operation with a set of numbers, and they will all act in a way that you know is predictable, right? So we all know stuff about like 1 plus 1 is equal to 2, right? So 1 plus 1 is equal to 2. Okay? Crazy statements here at alephmuvt YouTube and Twitch channel. So we know this because we know that the operator plus is pretty good. So okay, 2 plus 2, for example, is in fact going to be 4. Really close. You would think it is in fact fish. Hold on. Fish. But it's not. So we know this because this is a closed group. Everything is, it's an infinite set. It's an infinite group, specifically a field, because we also have multiplication, and multiplication was very nice. Now, let us take, for example, let me start writing smaller. So suppose I had a set that works upon these rules. It is not 22 terrified games. That is called a concatenation. You do not put the numbers together, right? Just because I have a cat and then I have a dog does not make it a cat dog. Okay, that's strings and other things. We do not use those. We are here to use numbers. So let us talk about the order. Let's say the group Z, and it's written like this. Z, I want to use Z sub 10. So in this set, I have the numbers 0 all the way up to 10, but not including 10. So 0, 1, 2, 3, 4, 5, 6. Let me fix that. 6, 7, 8, 9, and just 9. Okay? So, the way that the rules work in this group is that if I go outside of the range, then I loop back. So let's take, for example, 1 plus 9. Okay? So since 9 is my last element in this set, then I'm actually going to loop all the way back around, and we're going to be a 0 then, huh? Okay? So that is going to be 0. And there's definitely a way for every single number to get to a 0 with one operand, with one operation. So let's say like 2. What number would I have to do to get to 0? I also have some soda right now and some coffee. So if I started right here and then went to 9, then I can go back to 0. But if I start from 2, then I can go back from 9, and then I can use that 8. So 2 plus 8 is equal to 0. Okay? And this is adding. I do not have subtraction at all because my numbers do not add in a way to reduce the value. That would be a negative number, and negative numbers functionally is just doing subtraction. But if you add negatives, then that's when you're allowed to subtract. This does not have subtraction at all because subtraction is actually got some quirks and is not closed under a set. So let's just keep this up. So let's say 3 pairs up with that 7, also gets you 0. Now, what happens if you add 0 at all to anything? 1 plus 0 gets us a very good number called 10. No, it is 1. Good job. Good job. So then, this is called the identity. Let me spell this better. This is the That is not better. The identity. So what this says is that whatever I plug in and I have a 0, then I should just get the exact same thing at the very end, right? Pretty obvious, right? If you had nothing, to something, you still have just something. If you have $1 million and give no shits, you still have $1 million. I don't think that's the right thing I'm trying to go for. Lots of things like that. So what's good is with this stuff, you can create a group. It's possible to get every single other number using an operation, right? So how do I get 6? How is it possible that I can just get a 6? Well, luckily for me, I could do 3 plus 3, and that would get me 6. Okay? I can get an 8 by 4 plus 4, and that gets me 8. So since every single number is possible to get from the set, and I have an identity, and let's say I need to know a number to go back to the identity, right? This is actually going to be called an inverse. Okay? Hello? Hello? So, the inverse. So, the inverse of an element in the set is usually going to be the number that makes it to the, well, that by definition is the number that gets you back to your identity. I need to write this in different text. So, if you're writing this in generic terms, let's say I have a z. What is an identity again? It's a number that doesn't change the value. Okay, so x plus the identity would get me just x. X does not change. If 1 plus 0 is just going to be 1. So then, for z of any n, the identity element is usually going to be, if I'm remembering this, the subgroups correct, the group stuff correctly, it's technically mod. It's a mod. It's a moderator. Modulo. Z sub n, the identity usually referred to as e, is gonna be 0. The inverse, we usually say a in the set, right? A and a inverse. A to the -1 is the inverse, and that is in fact going to be 0. Now, do you remember this from maybe like functions? F of x is equal to stuff, and then f inverse of x gets me stuff. But we know that f of f inverse of x, well, it's just going to get me that x back. Or the other way around. F inverse of f of x is equal to x. This is because these things that have been developed from the stuff back here. So these are the basics before we get to the fun stuff, which is fields and functions and other things. And another thing about functions as well, you probably have seen them from a graph. So let's say this is the exponential function, e to the x, and then the inverse function is going to be the natural log of x, or ln of x. Maybe I should use a different example. But something special that happens with inverse functions is that it's always going to reflect across a line. Write down the y equals x line. Y equals x. So point for point, this one will be like 1 comma e. And then over here, I believe the point would be inverse. E comma 1. Right around here. Cool stuff. So we know some functions are not inversible, are not revertible. But for groups and things, we're using discrete numbers and stuff. So that's good. Then, the next thing we can talk about is how a generator. Generators, how can I make the entire set using just one number? Well, let me go ahead and erase this end right here. And honestly, what I'm covering right now is just stuff that I'm reviewing on the top of my head with a book in front of me. So that's kind of, I guess we ball. It's me winging it again. Excellent. Not what I want. And then my cat dog is going to be gone too. So, not what I want. Okay. So, suppose I have a number from the list here. So, let me look at, let's say, the number 2. Okay. So, if I take the number 2, and I put these little things, this is going to mean generator. So, generate. Okay. Or generator. So, what's cool about generators is you basically, it's the only thing that you have to make the numbers work out. Or in other words, it's the only thing you can use to get stuff. So what that means is I'm allowed to use the number 2 and no other number to get everything else. So for example, 2 plus 2, I can only use addition and I can only use 2. And we're still in mod space 10. Okay. So if I go 10, then I just get and I loop back. So 2 plus 2, hardest question in the world. 2 plus 2, what is that going to be? Two squared. Actually, that is very important for us to use pretty soon. So, congratulations. That is actually very important because by definition, we can do lots of things real quick with it. And we will need to keep track of the squaring and stuff like that. Because in notation-wise, it will mean a lot. It actually does mean something very good. So, good job. Very, very good. 2 plus 2 is in fact going to be our 4, though. Yep. So, actually, yeah, I was looking back right here, and I'm like, oh, yeah, huh, that's true. Because what's going to happen next? We also could just leave 2 by itself. That's fine, because it is, you know, just 2. What about 2 plus 2 plus 2? Well, by definition, that's going to be 2 cubed. Catch you later. If you're leaving Carmomos, enjoy yourself. Peace. So we have 2 to the 3, right? Which is going to be 6. Oh, you missed one. 2. You meant to say 2. 2. 2. 2. 2. So actually, let me put this whole chunk back up there. No, that resizes the canvas. That moves stuff around. Nerd. We're learning. We're here to learn. It's a very academic setting. I will not be threatened. You're going to learn and you're going to like it. Okay, if I remember, I could just do this. Oh, yeah. Okay. And this is the best drawing I've ever done in my life. Oh, wait. I gotta unselect this thing. Go away. Five. Are you also putting hand signs too? Oh, that also reminds me. Terrified Games from Terrified Games twitch.television Terrified Games. I should have an emote for I should have an emote for hand raising, or make that a redeem. Yeah, that would make sense. What's up? Terrified Games from Terrified Games twitch.television Terrified Games. Tell me. I'm talking during the lecture. No talking during the lecture. This is discussion time because I'm still making things make sense. Of all the questions you can ask Terrified Games from Terrified Games twitch.television, that was the dumbest. What is it called? There's no such thing as a dumb question. Go to the bathroom. Go to the bathroom, go back, come back. I don't want to deal with this. Teacher, can I go to the bathroom? No. Why are you asking me? I don't care. I'm not your dad. Go. I don't have to tell you what to do. We're fully grown people with autonomy. We're learning about math. 2 + 2 is 4. Let me see. Okay, let's keep going. Okay. Next number we're going to talk about is 2 to the 4, which is 2 + 2 + 2 + 2 is equal to 2 to the 4, which it's going to be 4 sets of 2, which is going to be 8. Now, we have a special thing coming up. 2 + 2 + 2 + 2 + 2. Nepenthes, please. No interrupting the teacher during stuff. Lurking and listening. Good. No, it's fun. I like it. Pulling my leg. Well then, Terrified Games. Tell me what's 2 + 2 + 2 + 2 + 2. 5 2s. Add them up. What is 2 + 2? 2 + 2 + 2. Put him on the spot. 10. Wrong. 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 You're dumb. You're dumb. It's actually, by definition in this set, it's going to be 0. 0. It's clearly 25. 0. Get wrecked, nerd. It is going to be 0 because, by definition of the set, if you hit 10, then you loop back down to 0. Teacher's cheating. It's my class, it's my rules. I can do anything I want, okay? Because by definition, it is 10 mod 10. Modulo, right? Mod 10. Which means if I take 10 divided by 10, I will get 1 exactly, right? Of course. But what's our remainder? I'm going to make the remainder a different color. So the remainder, remember you guys probably have done this before. Remainder 0. It's a bunch of gibberish. It's a bunch of bullshit. It's a bunch of bullshit. No, plants make no sense. Why do they grow? Why are they being all green and stuff? Terrified Games, why is it that you're bad at Silk Song? I meant really good at 𝖘𝖔𝖈𝖎𝖎𝖙𝖘. Calling everyone out. Dang. So the remainder is actually just gonna be green. A color. What did I say? Red. Nothing on me. 𝖘𝖕𝖚𝖚𝖚𝖚, you're a NASA simp. I don't have the badge. I didn't know how to get it. I did. How did you get that thing? I forgot what you have to do. I don't know. Oh, but take a look here. What's so special about this 0? What is 0? You just had to watch the Artemis stream? Oh. Well, how long is the badge for? I didn't see it. I was watching Z's stream for it. Watch the NASA live stream for an hour. That's it at that point? Just the NASA live stream or a NASA live stream? I don't even want it anyway. Anyways, this has a special term, guys. What is this thing going to be called? What is this thing going to be called? It's got a special term. Starts with an I. Starts with an I. We have 2 I words here. You got a 50-50 chance of it. Boy, I'm really bad at taking notes. I don't write digital notes. I write things on paper. So. An Elden Ring badge, apparently. What? Raging Wolf Helm? Huh. Oh, it's for playing the game. NASA? More NASA stuff? Get out here, guys. Okay. This has nothing to do with space. We're going to do everything in our heads, and we're going to talk about math. Math is cool. Math is fun. You can talk about things without going to space. Did you know that? That's called we're not getting the kernel yet. We're not using those words yet. We're not using those words yet. We're not using those words yet. But shout out 𝖘𝖕𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝖚𝑚𝑜𝑚𝑜𝑠 Yes, we're gonna get. There's a special word for now. You know, using our terms we have right now. What is it called? No space, only dirt. This thing is gonna be called the identity. Yeah, identity. I should have left that as a poll. Identity. What's so special about the identity? I get to add it to anything. So if I do 2 plus 0, then I just get 2. Whoa. Not factorial. Don't say a joke about that. Maybe I'll go like this. Okay. Now we're not done yet because something special happens over here as well. What about 2 to the 6? Which is going to be 1, 2, 3, 4, 5, 6 2s. Why do we have all that BS to get 2 plus 2 equals 2? Well, because we need to know how we can generate something with the numbers we have, only with 2s, to get a number that does nothing. So it would be like if you had $1 bills, and you need to be able to make it do something that every other dollar bill can do. But specifically, you're starting with $1 bills. If that makes sense. We have loonies. You guys use maple syrup and moose coin. I'm not sure what you guys have. So what's cool is that 2 to the 6 is going to get us 2. You have loonies. So anyways, the numbers that I actually get from this, 2, 4, 6, 8, and 10. This generates me a brand new set. So if I take all of these and then shove them into a box, then I have what's called... Why do you have so many ones, Aleph? Which ones? Because I roll in cash. If I'm gonna have fat stacks, I'm gonna do it in ones to feel like, give me the illusion that I'm rich. You know what I'm saying? My dad gave me that one time. He was like, it was for my birthday, and then something happened. He gave me like $100 for something, right? Very cool, very nice birthday money. It's really nice. But then my dog had destroyed the bill. Don't even ask me how. And then I told my dad about it. I was like, check this out. What do I do? He's like, you just go to the bank and then you exchange it. As long as you have the serial number and everything like that, they'll just accept it and then they'll give you it back. So he ends up doing that. Well, I was hanging out with him, and then he gets me back a fat stack of, well, I guess $101 bills. And I kind of laughed about it because I'm like, wait a second, what am I supposed to do with this? You know, I can't buy big purchases. $50 in ones is like very, very funny to do, but I don't think anybody's gonna accept that. You know what I'm saying? You know, socially, it's not acceptable to just throw out ones for like big purchases. So I just slowly chipped at it for like snacks and things like that. Sometimes you like to pay shit for using rolls of dimes. I have quarters, I have dimes, I have nickels. I keep my change and I keep them in the little pocket things. If you have enough of those, you can throw them at people and it hurts. Uh-oh. Nice. First ban. Okay. So the numbers I get, do I have the exact same numbers as I had before? 2, 4, 6, 8, and 0. And actually, let me reorder it so that I have 0 first. 0, 2, 4, 6, 8. Do I have all the numbers I had before? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm sorry, 9. Do I have the same numbers here? Pretty easy question. I don't want to answer any more of these are trick questions. I'm sorry. Okay. How many numbers are inside of this box right here? Let's count together. Let me use my my toggle for this. Okay. So, and then let me actually see my thing real quick. So I actually have it between screens. Okay. So, okay. We have, dang it, I'm so small. It's not my book. Okay, we have 1 thing, 2 things, 3 things, 4 things, 5 things. We have 5 numbers here. Okay, so we have 5. Now, there's a special term here. There's a special term here. So the way I can phrase this thing, it is the generator. I can say with the brackets here, 2 made this work. And I'm going to use absolute value symbols. The absolute value of 2 to say, how many things do I have? So that number would end up becoming 5. So back over here, this is going to be called the order. The order. Oftentimes called the cardinality. Okay? So cardinality. For now, we're going to call it the order because it's going to help us out for just a moment. And we notate it like this. With, let me put a big red box around it. Let me put a big red box around it. Perfect. Okay, we're going to look at this in a bit later. So now, back over here, what is going to be the cardinality or the order of Z10. That means compared to Z10, so I don't like that Z. I can make it bigger. And by the way, what does Z mean in this context anyway? Z stands for integers. Or whole numbers. So Z10 refers to the set 0, 1, 2, 3, 4, 5, 6, 7, 8. And I write my 7s with a little hash because it's clearer to see. 8, 9, and that's it. Let's count one more time. Okay, let's count one more time. So, how many numbers do I have here? Let's count. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'm just doing this for fun. It's good. Okay. I'm gonna fault this 10 is 0. Hold on. No. We have to count. Counting numbers are good. There are integers. They're normal. So the cardinality then, when I put it in the brackets here, I'm sorry, the absolute value things, it is not gonna be this. I'm gonna refer to the absolute value signs, and that is gonna be how many things are inside it. And in this case, it's 10. Woo! So if we have a generator, we can go through our numbers and see what they end up making. Okay? Tyler, how's it going? I'm still gonna get the thing working. What's up? We're talking about cardinality and numbers and things like that. Help out Nep, she's catching up. So notice the number 10, okay? And then the number 5 over here, okay? So how do you think the numbers, how can I get a 10 from a, how can I get a 5 from a 10? 10 operate something is going to be equal to 5. Division of 2. Very good. Right? And we have exactly half as many things inside of this than we do over here. And there is an ad going to come up, so yeah. And he's like, count the bird, count the 2s. Don't worry about it. Okay. Now, let's go ahead and create the generator for 3. Okay? Let's go ahead and go through our 3s. Okay? So what we're going to do, let's go ahead and start with 3. Okay? So the next one is going to be 3 plus 3, also referred to as 3 squared, which also means, what is 3 plus 3 going to be? It is not 3 squared math-wise, by the way. Not multiplication. It is not multiplication. This just refers to us how many 3s we have. What is 3 plus 3? Let's focus on this part. Don't worry about this. 9. No. Very close. 3 plus 3. And now it's add time. Tyler, you subscribed. Thank you so much. That would be a 3. Subscribe tier 1. Oh my god. That's a way to do it. Good job. Okay. Sure. That's a good way to do it. Thanks, Tyler. It's gonna be 3 plus 3, which is gonna be 6. Okay, math like this kind of 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put them together. We have 6 things here. That's a thank you very much, Tyler, for subscribing. I will be using that money for stuff. Seems you got it right. Wow. Okay, so now let's do 3 plus 3 plus 3. Okay. Exponential. It's like it's exponential. Well, it's definition. It's by notation. Notation says this is referred to as 3 to the 3 for only this context. 1, 2, 3 things. Tyler, Tyler got it. Definitely not Nep. Sorry, Nep. Pay attention. It's gonna be 9. I'm sorry. No, you both got it. Good job. So mean. Single you out. That's fine. Yeah, you've been here the whole time. Thank you so much. Okay. So next part. This is good. Watch this. What about 3 to the 4? 3 plus 3 plus 3 plus 3 is referred to as 3 to the 4. Now, if this number is bigger than 10, we're going to subtract 10, okay? So, what do we get when we do this? 3 plus 3? Well, actually, we can refer to this as smaller terms. 3 to the 2, and then plus another 3 to the 2, which we got earlier was 6 plus 6. And then combine these together with our trick. If it's bigger than 10, we subtract 10. What do we get? Oh, Human, what's up? I remember you. We get 2. We get a 2. Wow. Now this is interesting. Because now, with this, I can go to the next step. 3 to the 4 plus another 3. As also referred to as 3 to the 5. Right? Another property is that we have these orders, these exponentials, and then we can just add them. If we don't have one, then it's an invisible 1. So just for notation, I'm just going to be using these. We know that 3 to the 4 is in fact going to be 2. Next number we're going to get is 3. So look, 2 plus 3, no tricks here. 2 plus 3 is going to be what? A bug. Focus! Focus, 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 focus. 2 to the 3. 2 to the 3. 2 to the 3. 2 plus 3. 2 plus 3. We can count it if we want to. So I'm just gonna go ahead and say the answer for this one. It's gonna be 5. Wow. Okay, another fun fact. Now it looks like we're getting the other numbers here. So compared to the last one, we were stuck in our even numbers that it looked like, right? 2, 4, 6, 8, 0, because we wrapped down from 10 to 0. Then we could go back 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. That's all we got. That's why we can only get these numbers from this set. But if we go back over here, we look at our 3, so we start counting by 3s. We have 3, and then we have 6, 9, 2, 5. So then, is it possible we can get all the other numbers back? So 3 to the 6. We'll see. So we have 3 to the 5, 3 to the 5, the last one, and then add another 3. 3 to the 5 plus a 3. We know 3 to the 5 is referred to as just 5 because we got this right here. Okay. 3 to the 5 is 5. plus another 3. No tricks. What is this number going to be? SS245. What does that mean? Superset? Subset? Subscript? Lamau. What kind of notes? Are you taking notes from class right now? If you have something to share, share it with the class. 5 plus 3 here is going to be pretty simple. It's just going to be 8. Okay? Now, we have 8 now. That's good. 3 to the 7 is referred to as 3 to the 6 plus another 3, which we know is going to be 8 plus 3. Because this gets us the 3 to the 6. So 8 plus 3, technically it would be 11, right? But because of our rule, we're going to subtract 10 back. Minus 10. So what do we get? 11 minus 10. This should be just 1, right? Don't. So actually, I can explain this. So we are making a thing with the rule because the reason why we keep dropping back is because that way we can actually. I let it back. I don't know why. I gotta work. I don't have any mods, so that's why it is what it is. Sorry. I'm currently working on some work. Writing people's fuck ups. So reports. We're blocked from bullying. Huh? Let me see. So next thing we need to worry about. So this is 1, okay? 3 to 7 is gonna be 1, okay? So that is the thing here, and then now we can probably keep going. 3 to the 8. What is 1 plus 3? It's gonna be 3 to the 7 plus 3, which is gonna be 1 plus 3. No tricks. 1 plus 3 is gonna be equal to 4. Okay. Now I think we have one last few ones. 3 to the 9 is going to be 3 to the 8 plus 3, which is equal to 4, right? 4, 8 to 4, plus 3. And that equals 7. Okay. Now, we have one last one. We're not using minus 10 because we're not bigger than 10. That's why. That is why. So, next thing we want to worry about is 3 to the 10. Now we have 7. Let me rephrase this. 3 to the 9 plus 3, which is going to be 3 to the... excuse me. What am I saying? 7 plus 3. So now, this is where we get to use the trick, okay? It's 10. Is 10 too big? If it's a 2-digit number, we're going to have to do something to it, right? Like what? Now we can get equals to 10, but I'm saying now we're going to subtract it because we don't want this. It's going to be the remainder. I'm sorry. So that's going to be actually 0. 0. Oh, no. Wow. Okay. Look at that. We have all of our numbers, don't we? We have You did it. You did it, Nep. Woo! Good job. Let's go. And Tyler, good job too. Let's see. So I have 1 right here. Okay? That's my 1. Do I have a 2? I have a 2 from here. Do I have a 3? I have a 3 from the beginning, right? Do I have a 4? Covered my 4s earlier. Right here. 4. What about 5? 5. 6. 6. Right over here. 7. We just got it. 7. Right here. 8. Over here. 9 from back here. And the last one is 10, technically 0, here. And thank you very much. I've been sipping and drinking soda and coffee this entire time. Black coffee. So, what this means now is that it's possible for me with just 3s to get all the other numbers from the original set. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? Which means that the set I get from 3 is going to be 0, 1, 2, 3, 4, 5, 6. The number after 6. 8. And then 9. Huh. So, again, let us observe something pretty neat. What about the cardinality? The cardinality tells us how many numbers we actually have. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, how many numbers do we actually have in here? It makes you feel better, Neb. I dropped in halfway. And I am just as lost. Yep. It's okay. This is elementary algebra. It's 10. Yeah, the 10. It's the order. Order or the cardinality is going to be 10. How many numbers do we have? Now, something really cool about this is referred to as a cyclic group. Cyclic because the numbers that you have can make every other number. There's a way to operate with these numbers and get everything else. Well, I suppose cyclic means that you can generate a lot of stuff. At least you can pick up what cardinality means. I mean, it's just Spanish of it. What? Just keep thinking the Spanish Inquisition. Not why? Why? How and why? Cardinals? Is it dressed like cardinals? I see. Okay. I mean, I actually haven't. Spanish Inquisition. Now, I remember about it. Wouldn't any set with 1 be cyclical? Now, you're getting somewhere, right? If it's possible for me to make a 1, well, that's true. Trivially, you can use the set with 1, right? Because you would just add up the numbers all the way up to 10, and then you would go back down to 0, right? The Inquisition, what a show. The Inquisition, here we go. Have you guys watched History of the World Part 1? That's what I'm remembering from the Spanish Inquisition. Mel Brooks film? Anybody? 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 No? You're into that Monty Python shit. I was just telling... Okay, I did a 3D CAD... Tinkercad activity with my students the other day. And we did a rabbit. And so I was telling them the bit about Monty Python with the deadly rabbit, right? So I was like, all right, kids, so we want to make sure that we make a rabbit. So first I made a normal average looking rabbit, and then I showed them, okay, let's make an ugly rabbit. And so I ended up just giving it the worst looking eyes, made it look like it was scary, and I'm like, okay guys, this is the killer rabbit, you know? Kids liked it. It was funny. They made their own models, and then I was telling them about the clip from Monty Python of the deadly cave rabbit. And so I pulled up the clip during class. I was like, hey guys, let's watch this together. This is what I'm talking about. They were like, it's no ordinary rabbit. And then the holy hand grenade and everything. I did the whole bit. It was great. It was kids thought it was funny. For some reason, they had enough patience to watch the Monty Python bit, which is nice. So pretty good. So spreading the culture as I go. Okay. Now, another fun fact. Let's go ahead and pick a different number, and we're gonna use an easier number next. Okay. What about the generator with 5? Okay. Let's generate stuff with the number 5. Okay. Now, we could do 5 to the 1, which is just gonna be 5. Okay. Then, now, we're going to do 5 plus 5. Okay? 5 plus 5 is referred to as 5 to the 2, which here, what is 5 plus 5? Don't mess up this one. This one is the tricky one. Two. No, not right now. No, it's not 2 right now. Really close. Really close. 5 plus 5. Count your fingers. It's gonna be 10, but because of the trick, Nep, can you tell me what happens? Yes, it becomes a 2. So it does not become a 10. It is actually a 0. What? Okay. Good job. No, that's it. That's it. That's it. Congratulations. High five. High five. Shout outs to Nep. What's this unicycle stuff you guys talk about? Let me see. It says here, you're not allowed to use... Oh. Unicycle is good for this because of the wheel you spin, you keep cycling through the numbers. Yeah, exactly. So think of it if you actually want a diagram for this. So if I go through my numbers like this, 0, 1, 2, 3, 4, bad 4, 4, 5, I guess it'd be like this, 2, 3, 4, 5, 6, right? So what this means is that what this numbers are, if we go from 5, we're skipping ahead 5, okay? Then we're going to be going back to 5 again, no? Right? So when I do that, I get this way to go back only with 2 things. And that I can only get 2 numbers if I add 5s. Okay? So the set I get from 5 is going to be only 0 and 5. Okay? Next thing, let's look back at the other numbers then, right? If we did 2s, I'm going to use a different color. If I did 2s, I would be going forward 2, 4. Hold on, what am I doing? So how many arrows do I draw to go back to the very beginning? 1, 2, 3, 4, 5. Okay. Looks like a beach. Now with 3 was a little strange, right? So let's see what 3 did. So we went to forward 3 to 6. Forward 3 to get 9. Forward 3 to get 2. So it happened to just skip everything just right. That it makes that we end up going over all our numbers again. Right? So that's why it takes us 10 steps to get back to the original. Did it click? You can weave a hold on. You can weave using a disc with a similar pattern. Actually, that's probably it then. Yes. So something very important does happen because of stuff like this. So if we look at, if you have 8 places, 7 strings, and jump 2 at a time. Yes, 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 yes. Yes. Very good. So that's exactly it. So we want to have, depends on where you start. So let me do this again with, let's say, one more number. We're gonna use something like let's use 4 for a second. Okay. So let me go back and use the analogy with the let's see. So 0. Hold on, going around in a circle. Let me write it. 0, 1, 2, 3, 4, 5, 6, 7. I'm writing that wrong. 2, 3, 4, 5, 6, 7, 8, 9. So let's start with 4, okay? What color do you want 4 to be? Think of a good color. If it's like magenta or something. Blurple. I always tell the kids blurple. And they're like, that's not a color. And then I look it up and it's like, guys, get your facts straight. It's actually a color. And then they laugh because they're wrong. So let's see. So pick a color, any color. Started going way through recently and I understand the pattern so I could fix it with strings. Fix it if the strings dropped. Let's see. If you don't pick a color in the next 10 seconds, I will pick a color for you. Because I want to make it desirable. Green? Green? What kind of green? Light green, dark green, puke green, snot green, swamp green, sea foam green. Well, let me look that up. I could actually brighten the hex color if I want to. Oh. That is a good green. Let's see. Hex value 00FF80. Okay, got that. So let's look for the color. RGB alpha 00 FF. Oh wait, down here. 00FF80. Ooh. Hex colors. Yummy. Excellent. And I say I'm not an artist. I only know enough about this program to like make things work. I did enough stuff. All right, let's count our 4s. Let's count our 4s, kids. And we have another ad in 3 minutes. Let us get this one done. So we start from 4. We're starting with 4. We're gonna go forward 4 steps. 1, 2, 3, 4, all the way to, we're gonna go to 8. Okay, let's count 4 more steps. 1, 2, 3, 4. We go to 2. Then from 2, 1, 2, 3, 4. Huh. And then from 6, 1, 2, 3, 4. We got to 0. And then of course the last one, 1, 2, 3, 4. We go back to 4. So how many arrows is that? Let's count it. 1, 2, 3, 4, 5. So if I was to generate 4 from this, then I get the set. Still, I only get the set 0, 2, 4, 6, 8. So, forgot to count the 4. Forgot to count the 4. Haha. Technically, yeah, we don't have one pointing to it. 1, 2, 3, 4, 5. So, we have only 5 things again. So, the cardinality of this set is just going to be 5. Okay? So, there is a theorem. A fantastic theorem. I believe it is the cyclic groups theorem. Hold on. That's a corollary. So, another fun fact about 10, okay? If we're talking about the number 10, take an observation. Let us do our prime factors of 10. Why do we want to do prime factors of 10? Do you remember how to break up a number into its prime factors? Let's take the number 35, for example. Okay? 35. Well, I can break the number 35 up by 5. Why not? 5 and then 7. Okay? Because I can break it up into its prime factors, that means if I had such a thing with 35 things in them, I should be able to find a way to make 2 different subgroups. I'm going to be able to generate things that either have 35 things in them, 5 things in them, or 7 things in them, depending on how you skip things and count things. Let's do I don't want to delete. Let us do another one. Let us say 16. 16 is actually a better one because we can actually talk about that more. Let's break it up into 8 and then 2. Okay. What about 8? I could split up 8 to be 4 and then 2. And then I could split up this last 4 to be 2 and then 2. So I can find groups with 2 things in them, right? If I have the group 8 and then I did, let's say Z. It's an add time. Z sub 16. And I'm referring to mod 16. So if we go over 16 over, then we go back to 0. Then what I get is 0 and then 8. Okay? You're now able to surpass 1 million logs per second. Excellent. I'm happy about that. 1 million logs per second. Yes, good. So we can find things with 2 things. I can find things with 4 things. So what about the generator with 4? Okay. I can find things, 4, 6, 4, 8, 12, 16. So it'd be 0, 4, 8, 12. And this has 4 things in them. What about 8 things? Well, I could do 2s, right? 2. 0, 2, 4, 6, 8, 10, 12, 14. Okay? Get more dormice? What are you guys talking about? 16. What about 16? Can we make... Oh, a beaver clicker, huh? Gonna nab your 15th field trip in a sec? You gotta show me what this beaver clicker thing is later. What about 1? right? We can count our ones, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15. So 0, 1, 2, dot, 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 dot. All the way to 14, then 15. Then it goes all the way back. There's 16 things here, right? Now, there's another number that we can divide as another not prime factor, divisor of 16, right? What about the divisor for, let me see. The divisor for 16. Can't I do 16 as 16 times 1? Yeah, right? So how can I possibly create something that has only one thing in it? If I'm constantly adding things into itself, how would I make sure I only have one thing and I stay with only one thing? In other words, if I keep adding itself, it stays the same. What is that referred to as? Zero. Excellent. So if we just add zeros amongst themselves all the time, 0 plus 0, still just going to be 0. So if I use the identity, the only number I'm going to get is just 0, which means the cardinality of the identity set should be, the cardinality of the generator of the identity should be 1. And by definition, this is also very convenient to use so that you know that this is the identity. Doesn't matter how many times you add it, it's going to be itself. And you're never going to break out of it. Now, I believe there is a term for this. It is a theorem. This is the phrase of the excuse me. Yeah, because you add nothing, it stays the same. Yes. So this here, man, I wrote a lot. Oh my gosh. That's kind of cool. Let me open up a new layer and then fill it in with oopsies. Wait, so it's not 0 equals 1. The cardinality of 0 is 1. Yes. How many numbers can you have that make... how can you use a number to make things in a set, right? Hold on, what's happening here? This is the part where you get lost. Teacher, can you go? You can. You're welcome to leave. I was going to show you the fundamental theorem of cyclic groups. And it's a theorem. It is the most important thing in kind of group theory, actually. One of the most important things. It's not like a thing called the fundamental theorem of abstract algebra, because that's not really the phrasing. If you don't want to be here, you don't have to be here. But, let me see. So, this is actually a fundamental theorem. It is important for the entire basis of abstract algebra. And stuff like spirographs, the thing that you use, 𝖘𝖆𝖔, VT, it is important for, let's say, making patterns. And you want to make sure your patterns do not interfere, because if they interfere, that means it's a subgroup. I could show you an example. Maybe there's an online spirograph drawer. Online spirograph. So, for math people, I need a math person way of talking about it. I actually have a robot that the kids have used, and I have to make sure that they end up using it correctly. Because if they draw their spirographs too in sync, then they won't generate a good pattern. I've always wondered, the fundamental theorem of calculus, abstract algebra, abstract algebra, who gives that title? So, because it's It is the most important basic thing. It's, I guess it's a consensus to call it the fundamental theorem. But because of things like, people have used these for different times of the, history, and some of these fields have been developed fairly recently. It wasn't referred to as that at the time, right? Nobody just says, I'm going to create the fundamental theorem of, physics, right? With math, it's a lot of like testing, making rules, making axioms, and then coming back to it and then saying that you tested things out and this is the most important thing ever, right? So you got to make sure that you have something V theorem. I know, if only V theorem had more math people. If only something about something about people doing theorems. How do you not have math? Literally, theorem is a math thing. That is like the whole point of a theorem. It's a fact, it's a statement, and it comes from logic and things like that. There aren't any math people. The only one that's doing math is the space one, an astrophysicist. And there's no theorems in space. I mean, I suppose talking about like related rates and orbits and things like that, but that's observed calculus. I love when they drop the title of a movie in the movie itself. Guys, we have to be the Titanic, okay? Guys, we have to be Garfield 3. To be fair, Mylan does statistics sometimes. Yes, okay. So I will give Mylan the benefit of the doubt. They do statistics, okay? Something I do not do. Now, statistics does have a bunch of theorems in it. And it is pretty interesting. There's especially for like linear regressions, chi-squared, stuff like that, p-value, it's observed things. The 30 60 90 rule? No, what's it called? The 60 67 90 crap. The thing with the Gaussian curve, the thing that goes like pew, pew, pew. The 2080, no, not 2080. About normalized curves. Standard distribution. Yeah, normal distribution, right? So it's one standard deviation away. All of that crap. What happened to my thing? Can I draw? Can I draw? Stats is better than calc. Oh, how wrong you are. What's happening here? Why can't I draw? Only works on vector layers? What was this thing? Why can't I see this anymore? Flood fill? No, it's okay. Go away. Something's operating right now, and I guess I can't do it. Calc is for your calculator chat. Thank you, Terrified Games, from twitch.tv, Terrified Games. They say it involves math, but it isn't math. That's how they describe it. Oh, wow, look at that. I did everything all at once. I like it. Okay. There we go. Okay, finally I have it. Am I using slang? Yeah. So calc is short for calculator chat. Which, by the way, for those in the chat, you need a calculator for this. So can you guys tell me what what was it? Tell me what 10,000 plus 10,000 is. I bet you can't do that without a calculator. 10,000 plus 10,000. Bet you guys can't. 10. So wrong. Here, I could show you real quick. If it's not 0. It's gonna be 0 again, isn't it? let's see. Okay, hold on. What was I doing? Fundamental theorem. Okay. It's gonna be 20,000. You cheated. You cheated for that. You used a calculator, didn't you? Half the number of warhammers. Wow. I can't do it without a calculator, right? How'd you do? Mm-hmm. Well, you just gotta use a calculator. I have one right here, and it's pretty good. So, Warhammer 40K. I should put Nep on mute. What's it called? Timeout? War? Oh yeah, where's oh, is it Holland? I don't know how to pronounce their name. Okay, let's see. We're talking about the fundamental. Oh, I'm gonna take forever typing this out. Let's just look up on the internet. Fundamental theorem of cyclic groups. And there is a proof for it, but we're not gonna do it. Let me see if it's also on the theorem of the day website. Let me see. So if I search for it, it should be popping up. Today's complete listing. Let me look for fundamental theorem. There is a fundamental theorem of algebra of cyclic groups. Probably this one then. No, fundamental theorem of algebra is something completely different. Nope. So, theorem of the day doesn't have it. We're going to use 𝖈𝖐𝖆𝖆𝖕𝖎𝖎𝖙𝖘. Where the hell can I find it? Is this a good website? Frick AI is going to be misinformed. I'm going to be misinformed by the people. That's what it should be. That's what you want, right? I know I'm covering the screen still, so give me just a second. Cyclic groups. Okay, it is redirecting from the fundamental theorem of cyclic groups page, which is subgroups and cyclic groups. The theorem, let me look up the keyword theorem, states that in abstract algebra, every subgroup of a cyclic group is cyclic. Cyclic means that it repeats itself. So all the things we did with these generators and stuff, that means that it repeats itself. So that's what it refers to it as being cyclic. So when things spin, or when things move, when things tick, when they skip steps, but they go back to the original spots, they are cyclic. Okay? So the fundamental theorem states that for a finite group of order n, so if it's n number things, every subgroup is going to be a divisor of n. And there's exactly one subgroup for each divisor. In other words, if you look through the prime factors of n, it should be every subgroup should be able to divide it. So are there generators annual or perennial? Close enough. FromHiatus, hi. Welcome in. We are doing some abstract algebra. I really like this part because basically what it's saying is that if you have more subgroups as well, you can make things misalign properly, especially if they're coprime. But they'll meet up eventually in the end. Something like that. And I hope that the spiral graph thing that I can find right now would actually prove the point of it. Let me see more spiral graph stuff. You understand the concept. Good. Excuse me. That's my coffee. I'm drinking coffee in the middle of the night. 9:55. Oh, crap. I also forgot. I want to play a game. I do want to play a game. Okay, hold on. If I got the fundamental theorem of cyclic groups done, then what I can do next is that I can show you when things misalign. Oh, no, I can do this in Blender. Hold on. Yes. I can do this. I can actually show this. So, let's say I want things to sync up, okay? I want things to sync up in a way, and I need to know how many times it will spin, and I also need to know how many times they will eventually meet up, okay? So, actually, let me go back to the drawing program. So, let us say we have a counter, okay? We have a counter. So, I have a friend who, for some reason, they only count in threes, okay? 3. This also is related to, like, yeah, primes and co-primes and things like that, but for right now, let's just go ahead and use some of this stuff. See how many times it makes a rotation and makes it, or each time it hits the number. Let's do rotations, because I want to do, like, when things are pointing up or down or something like that. Don't worry. So let's say I have a friend that counts in only 3s, and I count in only 5s. Okay? So when do we meet up? Well, if my friend counts in 3s, we start with 3. Then they're going to count 6, 9, 12, 15, 18, 21, ... Okay. Now, I'm smart and I have hands, and luckily I have 20 digits. I can count with my feet and I can count with my hands. So I'm going to count with my hand first, 5. Then I'm going to count with my other hand, 10. Count with my toesies, I have 15. And then my last one, 20. And that is the biggest number I know ever. So, yeah, there you go. So when we meet up? Well, 3, 6, 9, 12, 15. 5, 10, 15. Look at that. Well, that is good to know, right? Now, what's the relationship between 15 and 3 and 5? There's some special thing right here. That's right. It is 5 times 3, right? 5 times 3 happens to be 15. Now, this is good because we will sync up every time we count a 15. So 15, 30, 45, 60. That's how we'll sync up. We're always going to meet up at every 15 then. So if I look farther ahead, and let's say I have more toes for some reason, 25, 30, 35. Actually, I don't even have to go too far. 21, 24, 27, 30. Okay? 30 is right here. 30 is right here. They sync up. That is exactly 15 away. Right? 15 away. So I will always be meeting up every 15. That's crazy. Now, some of you astute observers probably remember this from, I'm not even joking about this, elementary school. What is this referred to as? Maybe if we were talking about fractions, it's a little better. 1 over 5 plus 1 over 3. Right? To do this operation, we have to make sure they have the same denominator. So to do that, what we can do, how would one get the common denominator? I'm running out of coffee. Are you familiar with the term multiply? Yes. So, worst case scenario, you could just multiply them across, right? So, 5 times 3, and then 3 times 5. Just multiply by the other one. You're guaranteed to make a common denominator. Okay? So, let's say, for example, though, 1 over 2, and then 1 over 6. What can I use to add these numbers together? Do I have to multiply 6 by 2? Do I have to multiply 2 by 6? No. Correct. In fact, there's only one number that I need to multiply to get the common denominator. Multiply 2 by 3. Correct, Tyler. So times 3. Times 3. And then, yeah, of course, it's on the top as well. So, that's because this is actually called the least common denominator. Oh, sorry, least common multiple. Oh my gosh. Least common multiple. Least common multiple. What is a multiple? We just count our numbers by those steps. Multiple. Multiple. Close enough. So if we did this with 2 and we did this with 6, we would count exactly like this. 2, 4, 6, 8, 10, ... Then over here we have 6, 6, 12, ... Well, we can just stop already with this. Now, back over here, we do the same thing. We literally just did that. This is the least common multiple. LCM for short. And LCM is a big, important term. There is LCM and then GCD. For stuff like this. We're talking about LCM right now. Least common multiple. When do they sync up? Well, it's only the case that we multiply them together when they are referred to as coprime. Coprime. Coprime means they do not share any factors with each other. So let's take, for example, the number 17. And if I was to count my 17s out, I'm going to notice something. And I want the number 23. I am, in fact, literally using primes for these. But it'll work out because, observe. If I did 17, counted my 17s, 34, 51, 8, 68, Then 23s. 23s. Very convenient number. It will work because observe. I like saying things like that. Shush. So 23, 46, 69. I'm gonna stop there. Okay. So when do they actually sync up? Look, they were really close right here with 68 and 69. Haha. So do they actually have any common factors? Oh, shut up. Shut up. Love it. We're doing math. We're not doing something else. When do they sync up? How will we know that they sync up? I'm gonna just tell you anyway. Okay, so 17. Let's look at the factors of 17. It's only 1 and 17. Those are the only prime factors of 17 because it's a prime number. Okay, what about 23? It is 1 again, and then 23. When they're prime and they don't share any factors, then we have to multiply them together because that is the only time when they sync up. So if I have 1 over 17 plus 1 over 23, I cannot add them together because I need to make sure that they're split up properly. So I have to multiply by the other one. And in fact, what is 23 times 17? Someone tell me, please. I don't want to look it up. Use your calc, chat. 2319. So close. Is that right? 2319. 3 times 7 is 21. 2319. Is that really? Wait, what? 3 times 7 is... That's a ref. I'm looking it up. 23 times 17. You ding-dongs. It is 391. So, if this was like seconds, and my clock was set to be, something happens every 17 seconds, and then something happens for you every, 23 seconds, they will be syncing up at exactly 391 seconds. Okay? Every time. So, that means that, if I want to make things sync up properly, especially in like music and stuff, I gotta make sure that they have a coprime. So that's is where you get into things like polyrhythms. You get into, you know, counting theory and stuff like that. You don't necessarily need to know what those are. Maybe also it matters for like harmonics and stuff. I say that because I did some music and I know the gist of it. So, yeah, pretty neat stuff. Now, let me prove this by showing you an example with a 3D example. Okay? I'm going to use better numbers, so let's actually use something a bit smaller. Let's say 5 and 3 again. So 5 and then 3. Okay? If we think that they're going to sync up at 15 ticks in, then they should be meeting up in frame 15. So, let's go ahead and swap to Blender. Okay. So let's say I have a ball, okay? And let's change the workplace a lot. Here's what I'm going to do. I'm going to create a plane. I'm going to do a checkered pattern. You have a video to send me, but later? DM me that. DM me that, please. If that sounds cool. What is it? Is it appropriate to say in chat? Is it not weird stuff? You're not sending me more Capadon stuff? You're not bullying me? You'll be green with it? What does that mean? What does that mean? I'm green with it. You guys are saying something like it's a cult. I'm not certain what this means. Send more. Oh, you're saying some weird things. You're greasing your charms. Okay, I have an idea for this one. So for this, all I'm gonna do is that if they're facing towards each other. So let's say I'm just gonna use an arrow for this. Subdivide 2 times. And then it's going to be, I don't know, a green arrow. And of course I want this to be a duplicate. And then this one is also going to be facing. So here's what I'm gonna do. Here's what I'm gonna do. The idea is that if this thing spins at a certain rate, and if this thing spins at a certain rate, then they should be syncing up exactly at a certain amount of ticks. So, ooh, spooky. Let me change these to spotlights because it looks cooler. Area lights, excuse me. Yeah, they should have some ticks at some point that line up. And here's how you can make it look good with only a few. Like clock hands. This is the longest you're willing to listen about math ever. That's good. I am teaching you. So, I'm actually gonna make this a little bigger. You're learning. You're here to learn. I like to do these ones. Cranked up the brightness. Let's do... I made this way too big. I realized that. It's gonna be a little weird, but... Such a bloom, too. Well, to be fair, with any of the other, like, Vtheorem projects and stuff, I can keep up with almost every discussion. It's just, like, I'm not certain about a lot of the other particulars of things. Helps the tires being loud in class with me. Good. Very good. Or maybe not. I'm helping. I don't like these lights. There's too many. Okay, observe. I'm gonna do a solidify and make it a little thicker. 0.354. Solidify. 0.354. Thick. I mean, she's learning, yeah. This is the farthest I've gotten along to teaching somebody that does not like math. Well, I suppose lots of students, but in this case, she has the free will to be watching this anyway, which is very interesting in its own right. In its own right. Okay, let me create a new one. I'm going to create an outline. Voluntary. Voluntary. Blink 15 times if it's voluntary. If you're under duress, say... math is cool. Math is lame. Or something like that. Right? Hold on, can I wink? Vehemently dislike math. Willing to annoy you. That's... Okay. That's why. What I think. Of course, duh. The whole point of being here. Calling camera. Okay, so another cool thing that I get to do is that if I create another solidify, I can choose which material I use. So, observe. I can create an outline. So then this one is going to be a... Gotta add the right one again. I want this outline. And the number I want is 0.58. Dang. Nice. Okay. I'm gonna make the outlines a little thicker. dummy thick. Nothing wrong with magic. Just feel like playing with magic. It is. I want these to be a little closer. And 3, 3. Like they're touching tips. Okay, here's the trick. Okay, what I have here is a sphere, a ball, a blue ball, if you will. What I'm gonna do is I'm gonna look at the origin between these 2 points, create an empty object, and then I'm gonna have the camera looking at the object, the empty object. Track 2, empty. So now, if we look at the camera view, blue balls. So I don't like this angle. I'm gonna make it a little higher. Actually, yeah, this is a good example of what's really happening right here. Okay, so here's what I want. I'm gonna spin this thing around. I want to say I want this thing to spin 5 times in 50 frames. So I'm gonna start with this real quick, and then it's gonna spin 5 times counterclockwise. So what's cool about Blender is that I can literally just type in the number of times I want as a math operation. And I'm lagging. Oh, hella lag. Oh, wait. Am I alive? What's making me laggy? Hold on. Oh, I'm alive. Okay. So let's say I wanted to turn like a number. On the top corner right here, what you can see is, let me make it a little clearer. I have a bunch of like windows and screens. I can't even identify which one I'm talking about. Is this the one? Nope. Come on. Crap. I'm gonna put this on the top a bit more. That's why. Hold on. This one, go out of the way. Wow, crap. Okay. It's a pain in the butt. Whatever. Anyways, what I'm allowed to do is that I'm allowed to actually specify a number. So it says over here, rotation minus point, 100, 200, whatever the case is. I'm lagging. So what I can do is just say 360 times how many times I want it to spin. So let's say I want it to be multiplied by 5. So, and I want to make it a linear interpolation. So within 5 frames, 50 frames, it does in fact spin 5 times. Once, twice, 3 times, 4 times, 5 times. I guess that means, let me actually scale this up and do 60 frames per second. Spin. Sorry. Spin. Spin. If you know what that's from. Pressing play makes everything slow. I think I know why. Let me make this solid real quick. So we're looking over here. Man, I really set this whole thing up. Didn't I? Okay, so let's say I also want this thing to spin. Starts from a number, and I want this thing to spin exactly 3 times, right? So I'm going to spin minus 360 times 3. So do they ever sync up? And I want this to be linear. This is a moment of truth. This is it. Moment of truth. Ready? Observe. Do they ever sync up? Ah. So, let's go a little slowly. First cycle, 5 hits here. And we're a third of the way in. By the time this is done, it's about a fifth, 3/5 of the way in. The blue marble's about 3/5 of the way in. Or, I guess it did one whole spin already. Then, over here, if we do another cycle, we barely spun twice on the red. This one, now we're going to start syncing up. Yeah. It's like watching the blinkers at a red light. Yeah, you know. It clicks a different. So that's it. So they will never sync up unless if they're coprime. Oh, and then the rules of looping videos is to know where it starts and ends. And I know it's lagging me a bit. So we can do this with any spin. We can do this with any spin. So what 2 numbers do you want to check to make sure that they actually line up? We can check to see how many spins it does take to do it. And hopefully nothing too big. Where's your turn signal when you have to turn signals? And their signals turn when theirs is different. 18. Okay, we could do 18. So 1 could be 18, spinning 18 times per second. Or 18 times eventually. What's another number we can use? Minus 360 times 18. Okay, so one of them is going to be HoloNet. Okay. Also, is this Eevee? Viewport, I want it to be 8 real quick. No shadows real quick. And I can space this out too. What about this one? How many times do you want the second one to spin? Just keep it at 3? Because look, they do meet up at the end anyway. So actually, let's see what this one looks like. So because they have a common factor, maybe we have to spread it out a bit more. So I'm gonna double the time on it. So why is it? Hold on. Actually, wait. Oopsies. Huh? It looks like they meet up here at some points. Forgot from the numbers. and 8. We'll do 18 and 8 at some point. So do they sync up? They should. So this thing is supposed to be spinning about... It's just, I guess the frames don't look perfect. There it is, that's why. Yeah, so this syncs up, I think, every 3. Because... every 1 revolution of the red one, they're gonna sync up because this one's gonna, the blue one's gonna spin 9 times or 6 times then, huh? We only did 6 spins, so let's count the blue one. 1, 2, 3, 4, 5, 6. So that was 6 spins, and they can't sync up because they have a common divisor. So let's go back to the thing real quick. So because 18 and 3 have a common divisor, 18 and then 3. So not co-primes. 3 and 6 then, huh? And then 3 itself is just 3 and 1. This kind of ties in with like groups and stuff like that, because you need to know when things are starting to have similar properties, basically. Man, I did say I did have a game, didn't I? I think I'm gonna finish this one up, render this one for several times, and then I'm gonna play some games. How does that sound? Yeah. Okay, I'm gonna save this project, and I can always change the number that I want. So this one needs to spin 15 times, and this one needs to spin 5 times, which is probably a little better because we can see that. This one needs to spin 15 times, so minus 360 times 15. And then this thing needs to spin 360 times 5. So they should sync up every time. So 5 spins, 3. No, because the coprime number is going to be 3, right? If you divide 15 by 5, it's 3. 5 itself is just going to be 1. So 1 revolution is going to be... And then this goes to ratios and stuff like that, and all that crap. So every 3 spins, it's going to sync up. Which means they sync up 5 times, don't they? So once, twice, 3 times, 4 times, 5 times. Yep. Okay. Pretty cool. I'm going to save this project. We're going to call this one coprime spins. And then I'll have a fuller animated sequence for this. But we got the background and concept and everything like that. Cool. Okay. I do not know how to transition this, so let me see how I can do that. Go to... Depending on what it's gonna be. Let me look at Studio real quick. Okay, it should be right. I was playing around with it last night. So, there is a cool game. I did mention it's called Marble Marcher. Marcher. Itch. I have to open up the itch page for it. Okay. We're gonna get started on our last thing for tonight, and then I'm probably gonna go wrap it up. Still probably gonna drink coffee and study a bit more, but kind of remembering some of these things is good. Cyclic groups, generators, finite cyclic groups, all that stuff. Cool stuff. Okay. Okay. Can you have some coffee? Do you like black coffee? Or do you want cream and sugar? Or just milk and sugar? Or milk and cream? Or sugar and sugar substitute? You should be learning. You will. I think learning just comes by osmosis. So if I'm putting the effort to like learn something, it's kind of cool for everyone else to kind of like, oh, I see what they're doing. You know, I see what he's doing. So it's good. A splash of milk. A splash of milk is good. 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 Sorry about that. My ears are bleeding. Okay, getting it all set up over here. So the lag is good. So let me close this real quick. Let me go ahead and transition. Let's go and transition, guys. Let's do it. What? Hold up. Ready? Let's go. Let's go. Let's go. Let's go. Hopefully there's nothing weird on the other end again. Okay, here's what we got. This is a game. This is a Fractal game. So I probably do want to actually play the video for it. Good country lag. Let me close some things down. So close that. And close Vtuber. Let me close the Krita. So, let's see, call this algebra prep. Okay. Okay, this is done, so I'm going to close that. How am I doing computation-wise? Dragon curve? Dragon curve is actually really cool. I do want to do some like programming tasks and see if we can make it ourselves. Let me see. Okay. This here, I don't think you guys can hear it. I'm just going to use my desktop audio for this. So how does this sound? Can you hear anything? Okay. I don't want to blast your ears. Okay, that's a little better then, huh? Is that better? Okay. I am trying to go for, because I can hear it blasting in my ear, so like it's loud. And an ad. Wow. Actually, this is good because then I can take a break real quick and then get some more coffee and then play this game out. This game is not a long game. It's a very humble few-ish levels. Actually, the sound is gonna destroy me. So because it's tied with the audio. No, that's right. Never mind. Okay. So this game is a really cool game. It is a Fractal game. So this is done in OpenGL. This game is like made from like the programming ground up. So it's only like a few megabytes big. It does not use any real models at all. It uses procedurally made stuff. So because this is running real time, stuff like my computer is trying to crunch these numbers to make it work. Now there's a way to make it a little smoother, and I can go back down to that setting, and if that's possible or necessary, then I will do that. But let me see how performance is on my system, and what kind of a coffee you're going for. What kind of coffee? Oh, my GPU is cranking it. Ooh. I don't think this is gonna be a good experience. So what I'm gonna do is I'm gonna have to close it and then redo the settings. So let me do, dang it. We're gonna do, let's see 𝖘𝖔𝖈𝖎𝖆𝖕𝖎𝖙𝖘 real quick. Do that, close it, reload it. And then how's GPU? 91%. I think we're just gonna have to go original then. Simple. That's fine. One day I'll get a big boy computer and GPU, and I'll get all the cool things I want. Maybe I could get that for my birthday. One more time. Yeah, that's fine. Happy birthday. Yeah, this is competent. This is better. This is fine. So I have an ad in 30 seconds. I'm gonna go and grab some coffee and I don't know, pee and stuff. So you guys go and do your thing, and I'll be right back. Okay. Let me look good looking away. You're right, I did forget to pee. Give me a second. Okay, I am back. I do not have any more coffee. I had barely like enough. For like, I guess like a squirt of it or whatever. So I'm fine. What I'm gonna do is probably we'll finish this game out. It's not a long game. We'll try to get all the levels done and, you know, just explore a bit about this game because it's really, really cool how bare bones this is. It's generating these in real time, which is what I said. It's so cool that somebody made a program to do just this, you know, and it uses a lot of math behind the scenes. And this is the kind of fractal stuff that I actually really, 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 really want to make. So the fact that it's done in like programming is much cooler than like, let's say Blender, because it's computationally dense, it's a render engine. This is done as optimally as possible. So like it is, once you get down to like low level code, then you can do crazy stuff like this, which what I want to learn. So maybe we'll do a stream. I'm trying to get OpenGL working. And I just got to review my C++ and then we can definitely try some things. All right, let's go ahead and get started. The way this game works, it's your marble, and you get to be on the thing. Just get to the endpoints and just go. Your tea's not ready yet? I'll wait. I'll wait. You know what? You know what we can do then? Let's look up the video. Let's look up the video of the thing. So let's do Code Parade and watch the video live. What it's about. Let's see. And there's a few games that he's done before too, which I really want to try out. We're gonna watch a Marble Marcher.
Playing on iPhone? Now you can.
Shush. You can hear all my audio, which is kind of scary. Anyways, let me quit the game real quick because it really won't take much time to like start it up. Blah blah blah. And let's load up the video. Let's go ahead and watch it. So what would I want to do? Window capture? You guys can see everything, which is bad. Okay, let me see if you guys can also hear this as well. So what is this one called? Let's see.
Yeah, 3D.
Can you guys hear that twice or what? Why are you playing on iPhone? Yeah, okay, you can hear it.
Fractals are awesome, but then why do you rarely see?
Oh yeah, I don't have an iPhone. That's the best part. I don't use iPhone anything. This is all like nonsense tracking. It works. It works. I don't know. Okay, are we ready to watch this? This is a 4-minute video. Really cool.
Yeah, 3D fractals are awesome, but then why do you rarely see procedural rendering used in games? I mean, ray marching unlimited objects in real time seems really useful, right? Well, the problem is, sure, there's efficient ways to draw these objects, but how do you actually interact with them? Well, I'm going to show you Marble Marcher. It's a proof of concept to show that fractals aren't just fun to look at, but real games can be built with them using a fractal physics engine. The download link and source code are in the description. If you want to understand how ray marching works, you'll definitely want to check out my other video on that first. Otherwise, some of this video might not make any sense.
Now, real quick, I do want to say he does have a few more videos talking about how the process is, right? I remember watching this when I was, this is 8 years ago. So 8 years ago, that was me back still in in school, in high school, I think. So yeah, I saw this and I thought it was the coolest thing ever, and I was like, oh my gosh. Later on, what the graphics class that I ended up taking was OpenGL, and this is also OpenGL. He seems to be a graphics developer. So one of all this stuff is like stuff that I really want to do. It's game design, it's 3D, it's models and stuff, and I can do the modeling stuff. What? And it's all making things from scratch, right? I don't like real data. I don't like making things with, I want to play with my numbers and math and make it all work. And if it's a physics engine, it is actually not that hard to incorporate. In fact, in this case, you just run some simple physics parameters, and the only thing you really need to keep track of is just the ball, right? And once you learn a few things, then that's it. Like, people make things look more complicated than it really is. Yeah, make more things work just doing the theoretical part, This is why I use colored pencils. Take a look at these.
So what do we actually need for a physics engine? The most critical and difficult piece is collision detection, and that's why it's often the biggest source of glitches in modern games. Collisions are fundamentally difficult because the math is complicated and expensive.
Ooh, let's go back a bit. What paper is this one? This one is, let's see, fast triangle intersection test. This paper presents a method along with some optimizations for computing whether or not two triangles intersect. The code, which is shown to be fast, can be used in, for example, collision detection algorithms. So, and then the math, of course, is quite dense. You don't have to learn about that, but I like, actually, what kind of stuff does it have right here? Parameter line parameter value T1 for B as the, what is this? Denote the two triangles T1 and T2, the vertices of T1, T2 by V sub 0 script 1, V1, 1. Oh, these are the vertices. And then the other one, V1, 2, 2, respectively. The first plane equation, pi 2, pi as in plane, not pi for the thing, is defined as these things. There's actually a lot of actual calculus and things like that make these kind of cool. Not surprised collision is difficult. It's not just, it's something here making contact versus not there is making contact. Yeah, so it's a lot more complicated than it is. And I actually really enjoy hitboxes and stuff like that. I was doing something recently with a student. We were doing a turtle algorithm stuff, turtle stuff in Python, and I was augmenting it so that we can do a collision square, And the simplest way I can describe collision for it was that if it occupies the same space, if you get the turtle's position to be inside the same space, then something happens, right? And that means literal coordinates. So if it's within a range of coordinates, then you can make something happen. I will have to pull out the project later to show it, and it's pretty primitive, and might not. Well, actually, mathematically, it's not too tense. It's just a check. But since you're constantly checking, it's I wonder what it means computationally. I mean, it's Python, so it's a lot of overhead. Let's keep watching.
Expensive. So games make a lot of approximations, and they're always trying to balance accuracy with speed. And even then, after a few thousand objects, things typically start to slow down.
What?
Now we should have an opportunity to do better, because rendering a fractal is really only rendering a single root object with a bunch of transformations and folds applied to it. So how can we transfer this to the physics? Remember how fractals have a really efficient distance estimator? Well, this is actually really useful. If our object is a sphere with a radius, then just by checking the distance estimator, we can immediately know if we're intersecting or colliding with the fractal if the distance is less than the radius.
Now, he covers this bit in another video. The algorithm is actually pretty cool. And, I might be able to use that for some things in the future, but it's a really good resource to know stuff like this for shapes of all things. Spheres. So cool.
Problem solved, right? Nope. Knowing that you're colliding with something isn't enough, because you also have to know how to react to the collision and unintersect yourself. And it's not obvious how we would get that information efficiently. So I'm going to put a big twist on everything. Normally, you compute folds and transformations a bunch of times and then finally take the distance estimate of a root object. But let's say instead of computing the distance, you compute the closest point. Okay, but the closest point on the root object isn't actually that useful. Once we have it though, we can just unfold that point by undoing all of the transformations until finally we have the closest point on the original fractal. That means it's just as efficient as computing the distance.
So that bit right there, I'm still trying to wrap my head around, is that because of the scaling method, you can just kind of like average it out or something like that. Is that not right?
The point on the root object isn't actually that useful. Once we have it though, we can just unfold that point by undoing all of the transformations until finally we have the closest point on the original fractal.
Oh, so you undo it. You're undoing the thing so that you can find which one had the closest one. You can find the points by just getting closer and closer and closer and closer, rather than computing it for the longest. So there's a few iterations that you do, and then you just go through the depth, and then you see if there's any of them happens to have it.
That means it's just as efficient as computing the distance. Using that point, it now allows us to update the sphere so we know exactly the optimal direction and amount it needs to move to avoid the collision. And that to me was an amazing discovery. It allows extremely fast, precise collisions with infinite objects. That inspired me to make Marble Marcher, a marble racing game where you race on fractal surfaces to reach the goal. Since everything is ray-marched, we can take advantage of a bunch of cool features like reflection, refraction, soft shadows, dynamic lighting, ambient occlusion, and since nothing is baked, not even the physics, we can actually have the entire fractal evolve during gameplay,
real time,
and everything just works. It even runs at 60 frames per second, no problems at all, though you will need a really high-end GPU for the high resolutions. There's one caveat.
I like how he says that. At the time, the comparison that people were talking about then was a 1080, a 1080 Ti and stuff like that. So,
remember how we're dealing with distance estimates?
It looks like an acid chip. Yeah, don't
play this high. To have the physics work, that estimate needs to be really accurate. A lot of fractals have perfect distance estimates, but some don't. I'm not sure what causes this problem. I think it is something to do with using a scalar instead of a Jacobian matrix in the estimate, but I just made sure to pick only fractals that worked, so it wasn't a problem. And yeah, this game is free and open source, so I really hope you give the demo a try.
Yeah, do you want to
It's truly unique, and I've never seen anything like this before.
I'll show you where you can find it.
I also really want to thank the artist Pettytheft for doing all the music for the game and this video. Be sure to check out his SoundCloud. And for anyone that dares to speedrun the game, these are my personal bests so far. Thanks for watching, and have fun.
Speedrun. So, we're gonna go ahead and play that. Should I? Actually, wait. I don't even know. Do we have any plans to like collab? Nope. I don't know. We like said something about that, but I keep forgetting whether you mean it or not. I don't know. Let's see. Let me go ahead and close this real quick so you guys don't look at everything I do all the time. Yeah, I think we have a planned something about anything. Do we have a collab planned is the question. Because even I don't know. I mean, the idea is there, like we want to, but I forgot about what. Probably something math related. Your favorite subject. And also, let me check for something else real quick, and then we'll get started. Okay. Oh yeah, we're gonna talk about inflorescences. That's gonna be good. Exciting, very fun stuff. Let me brush up on that stuff again, and we can we'll talk about it later then, okay? Let's go ahead and get started with the game. So, I can make it faster and get back here. Math of flowers. There is a really good article about that, and it does in fact bring up, you guessed it, fractals. So, really cool. So look, my game can finally run properly. So it gives you an arrow, and you can move over to the spot. Easy. Light work, no reaction. That's a lot of noise. Too many trees. Too many fish. Too many cooks. Too many cooks. Oh, that is noisy. That is extra noisy. What is this about? Really primitive graphics here. I say as I like. Oh, this is so cool. Hold on, look at the detail. All these ones are self-similar shapes. I really wonder how they do stuff. This is math? Yeah. Hi. How do I say your name? 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. Yeah. It's fractals. Guys, you might not believe I like fractals. I was just covering dang, you just missed the explanation for this game. It has a really good like math explanation behind, or explanation on how this one is made. And I cannot run it on best settings, unfortunately. But it works. Okay, after this level, I have no idea what any of them are gonna be. Okay, so this one's pretty cool. You just go down here. What is that? Yeah, Fractal VTuber likes fractals? What? What is this thing where it's like your Minecraft trip thing? What is this part? Whee! Fuck! Why did I reset? I clicked the button. That's the reset. Fuck me. Shit. I pressed right click. What the hell? Crap. Marble Muncher. Yeah, Minecraft AI, is it the one? I guess. Okay, right click. Found out that restarts the level. I thought it was just R. Damn it. Marble Muncher. Mm-hmm. No. Or Tyler, stop. Okay, what is this with you guys and Vor? Stop bringing it up. Vor. Okay, I won. Wow. Okay, guys, let's... Yeah. Started it. Did I just call you A? Or A? A started it. Around the world, around the world, around the world. So, okay, this bit, how do you think this might be easier to program? Are they actually using a physics engine like Super Mario style, Mario Galaxy style, wrapping around the world? Or do you presume there's an easier explanation for this? Do you think it's rotating the entire world, or do you think I'm wrapping around it? And I totally missed that. I suck. I think the entire world, right? Yeah, it'd be easier, you know, locally, non-Euclidean. Okay, this is our first transforming level. And if I remember, you can get crushed in these. It looks like it's moving around versus you around it. Well, I think it's just physics-wise, it's a lot easier to wrap around the world. And let's say just keep the physics, the ups and downs moving. Crap. But I mean, there's a chance that there's a way to wrap it. And, well, with OpenGL, you just got to make sure that you parent some things properly. I think I guess, because behind the scenes, it's tons of, like, matrix operations. So, as long as you, like, keep your physics, as a rotation object, or if I'm saying this correctly, basically you're wrapping yourself around, you're transforming, but the physics is actually, so I guess it could be possible that it's actually just wrapping around the world. And actually, I think it would make more sense for it to, because the way OpenGL works is that it's stacked matrix operations, and actually use that to do a polar system. Crap. Okay, reset. Okay, I suck. Yeah, it looks like you're still. But in this case, graphics are great because you can just do things your own way. You can run your own math on it, and it could work. I don't suspect it's actually the hardest thing ever. Oh. Okay, I gotta lock in. Fuck! Okay, I'm going the long way around. Okay, I'm not... I'm not bad at games, I swear. Okay, I thought this was just gonna be easy. Ooh, ooh, ooh. Oh, crap. Fuck! How do I... Okay, hold on. I only smart when it comes to plants and bugs. Oh yeah, if you like bugs so much, tell me your favorite beetle. Fuck! Not my favorite math VTuber? What do you mean? Shit! You're currently working on a presentation for beetles, are you? Favorite beetle is Beetlejuice. Now that can mean many things. Are you talking about was it a star called Beetlejuice? Or are you talking about, I like Beetlejuice from, ReZero. Beetlejuice. He's helping reformat some of the old PowerPoints on stream. Ooh. The movie? There's a movie called... Oh yeah, no, the Beetlejuice. Shut up. Okay, what was the name of this level again? Damn it. Rock climber or something like that? Damn it, I need momentum. The band Beatles is the top beetle. How do I ask you guys questions? Okay. Fuck. Ladybird? My favorite beetle... Yeah, ladybugs. Ladybugs are cute. My favorite beetle... let me see. My favorite... What is that called? Coccinelids? Coccinelids? Cat walk. Ooh, that's trippy. 24% of all life on Earth is beetles? Oh shit. Oh shit! Is that right? That was easy. 25% is a big number. Parentheses beetles your favorite. You know what? The big bugs, this big like stag beetles and stuff like that. Math beetle. I'd like to see a math beetle. It probably, I don't know, has like a big plus or minus sign or something like that. Actually, no, a number. So math designs are hard because how do you make things say math without it actually like just being a math symbol? Oops. But like if it's gonna be a math beetle, could a design on it just like a ladybug? Could it be a what would it have on it? Fuck. Species ladybug? These graphics are... I mean, if I had less noise... Yes! if I had less noise on this, if I could crank up the settings, I'd say it'd be really, really good. Yeah. Yeah. 10-minute run. And add in a minute and a half. Species is literally parenthesis? Really? I'm watching Vtuber. Ooh, look at this level. Hold on. Look at this. Crap. Crap. Oh, shit. You can just die. Okay, hold on. Guys, look at this Doctor Strange looking, No, crap. Oh. Yes. Marble munch. Stop the bulwark, guys. Sponge. This is where SpongeBob comes from, guys. Have coffee? Ooh, hold on. Look at the detail on this one. You know, the noise covers it up, but a lot of detail on this. Shit. So I wonder what algorithm it uses to generate the meshes and stuff like that, or how method is going to be used. You dying to steal this shoe? Stop talking. Stop talking. For our homework tonight, you guys are gonna have some crap. You're gonna have posted in Z. For homework, you guys are gonna repeat after me 50 times. You guys are gonna have to repeat something 50 times and make it smaller and smaller and smaller. That's the basics of a fractal. Shit. Yeah, and how did your assignments go? Did you win? Everyone knows that if you pass your final, that makes you the king of your field. So did you win? Got it. Repeat after me. No. What are the middle things in your pick? Which pick? Is this salamander? Crap. Got it. Stop moving. I need momentum. Complex analysis. You know, I actually never took complex analysis. Anything that has to do with complex numbers on the math side, I really kind of didn't do. Other than like some like proof stuff, but that's it. I don't mind complex analysis. I learned more about complex analysis in physics than I did in math. Oh crap, I gotta... Fuck! Be back in 1 minute? No worries. And then ad's gonna... Yeah, the ad's still here. He died. Thank you, Nep. Death counter? Death counter? Let's play a game, guys. Every time Aleph dies, you take a drink. Come on. This is a, alcohol poisoning? Come on, I'm a gamer. I'm like really good at this bit. Good one, Carmamos. Death counter N. Yeah, of course. Oh no, I'm saying if hey, I was like, game. It's a game, drinking game. Every time you die, take a drink. And they're saying it'll work out. It's fine. We're good. After this, I'm probably gonna get some food. I didn't eat anything. Well, hold on. I ate like some bread, like a bread torta, I guess. A bean torta. Got it. Mint alcohol. Oh, like peppermint schnapps. Schnapps. This game is. You tell if Aleph is cute and he gets shy. Hey guys, look at the game. Look at the game. Look at the game. Oh my gosh. Hold on, I missed the checkpoint. Post the Capadon. Guys, okay, I already showed it off earlier. I started off in the beginning of the chat of the stream today. And by the way, Nep, that's crap. It's so cool. I mean, okay, it's a really nice picture, and I haven't had anything like that ever. But that's just bowling. You're bowling. Guys, I gotta get to the end. I gotta get to the end. Let's get to the end, please. I don't even know how to get there. Okay, I actually gotta like get a little slower. How? How? Crap. Alright, I'm gonna go. Does this have a little bump? It does. You try not dying. Hey, you can't not dying. Fish. Have you tried doing math? Elementary. Yeah, yes, you did. No, I haven't. We got some crazy reactions from you too. Crap. Okay, so how do I? There it is. Okay. Oh, thank God. Okay. Watch this. Watch this. Watch this. Crap. I gotta roll. No. How do I get up here? Okay. Oh, hold on. Hold on. Hold on. You got it. You got it. You got it. You got it. Yes. 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 Okay. Got it. Got it. Got it. Got it. Got it. Got it. 𝖈𝖵tuber. What is this 𝖈𝖵tuber? What are you talking about? What are you saying? Irrational. What is 𝖈𝖵tuber? Tell me. It's hard. Where's the flag? Whoa. Oh shit. Crap. I'm a 𝖈𝖵tuber? What is that? Mew? The moo part? It's Mew. It's pronounced Mew. It's Mew. Mew. Like alephmuvt. 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 Because it's a Mew. It's Greek. It's Greek. It's the Greeks' fault. Come on. Come on. Come on. I think it's Moo. Where's the... Oh, there it is. There it is. It's over here. Crap. Okay. When it's moving, I don't want it to be the spongy one. I want the smooth one. 𝖈𝖵tuber. Honestly, hold on. I'd really like to... I don't speak Greek, no. Speak Feta? Okay, hold on. I'm getting there. I'm getting there. I'm getting there. Okay. Is it here? I mean, like, how hard can Greek be, right? You know, it's just like, Euro and, Eratosthenes, Plato and all that, right? Those are the classics, guys. Aristotle be like, hey buddy, you ever just think about stuff? And then Alexander the Great was like, hey, you know, it'd be really cool if I just owned the old world. Sure. I actually really like the story of Alexander the Great. Lots of really interesting bits about that. And I actually like the historical context after the fact, where the kingdom split apart. I was studying for my history class, and we're covering old world stuff, ancient history, and yeah, so like the Macedonians, the Persians. Well, the Persians were always there, but they're their own kingdom. So instead of just fighting for the, I'm not sure what the reason why was. This is hurting my eyes. Oh my gosh. Instead of fighting for the kingdoms and stuff like that, they kind of just broke them up by delegates. They're like, hey, you deal with Macedonia, which included Greece and stuff like that. You get Persia. You get I don't know what else there was. The Indies, or whatever the case is, the Indians. Please, 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 please. And then the other things. And then that was like that for a minute. Yeah, I died. I know I died. Okay, I need an explanation. I know I died. Wow. This is harder than I thought. How? I need to get out of this level. This is hurting my eyes. Come on, go. No. I'm not gonna do that. Okay, is there a trick? Okay, we hang out here. We tech this. No. Ah! This is a hard level. Screw it, I'm going this way. Scale issue. This is surprisingly hard. What the hell? It's called Get Good. You know, I'm pretty decent at most games, except FPSs and maybe some high-end rhythm games and horror games and actually a few more games actually. I don't play a lot of games anymore. I used to. Okay, where am I going? Hold on, stay here. No, we're not doing that again. Give it. What the fuck? I did I? Yeah, go this way. Okay. I'm locking in. I'm not reading you guys. I'm locking in. I'm hold on. Watch this. This is it. Oh, it's right there. Yes. Oh, okay, good. Oh, okay, hold on. There's more to this one, I think. Okay, this is only the beginning. If you need a break, take it right now. Challenge levels are coming up. Challenge levels. Okay, hold on. That breathing got me lightheaded. And the caffeine's got me, juiced up. Okay, hold on. I am gonna drink some more coffee. I do want to eat something. So I'm probably gonna go to some place. Probably gonna go get something like healthy food, like Jack in the Box or something. I'm not sure what you guys have. Okay. What I'm gonna do is probably I'm gonna try 2 more levels and then I'm gonna wrap it up. Okay. And by 2 more levels, I also gotta make sure of something else. Even the cute fat. What's wrong with that? What's wrong with the fast food option? Okay, this is getting ridiculous. Okay, give me just a second. I'm gonna check for something real quick. I want to eat. I want maybe. I want food, preferably something edible. I know I shouldn't be eating late because it's bad for your body. But this whole week I've been basically dieted because of my work. So I was quite preoccupied. So I deserve a big meal. Waste off the time of streaming, keep me disciplined and work. How so? So let me see what I'm gonna do. And I'm getting a massive headache right now. What's going on? Okay, where's my mouse? On my mouse. Resume. I haven't watched you do homework. Do you want to do like a co-working stream? Like, do you think co-working is cool? I don't know how I feel about doing that on the stream. I just feel like I'm boring. And you guys can like study at the same time. Lovely bottle. Hold on. I love body doubling. Yep, what are you saying? How is it all the way over there? Hold on. Okay, I gotta look over. Okay, you're saying what? I would double my body for you. Body doubling. What are you trying to say? The way to focus on your... Hold on. Let me get this. That's not fair. That's not fair. The way to focus yourself, just keep being present around others. Oh yeah, that's honestly how I operate too. Just being around people like makes me more stimulated and like my head, and I very much appreciate like the collaboration or anything like that. Now that's why like this entire thing before I started streaming, doing math in a vacuum, it sucks, and it literally is like a social. It's a social science. No, it's not. I appreciate talking to people about it. I like being social, talking about it. But here's the thing though, no one likes math. No one likes talking about it. So unless you like have like good knowledge of it or just are a really good teacher yourself, then people usually don't give it the time of day so that you can like learn. Now if only people at school cooperated more. Yeah, we can force people into math camps. Hear me out. Hear me out. Oh, this is a cool level. Oh, this is a cool one. Hold on. Math camps? That's illegal. It's illegal. Whoa. Okay, hold on. Let's go. No. Okay. Okay, I see what's going on here for this one. What a cool thing here. This is like the kind of environmental stuff that I wish I can do for my 3D stuff. That'd be really cool for like, backdrops and things like that. Maybe I should start using these for my schedule. Which, by the way, I gotta make my schedule for this week. I think I'm streaming tomorrow. I think I am. I gotta double check because I'm pretty sure I don't have work. But who knows? And I need to do my tax stuff. Crap. I mean, yeah, this year it's also not good for me. I owe money this year, so bummer, but not a lot. It's triple digits, not that bad compared to others I've heard. So, our taxes are due in a few days. Woo! And glad your taxes are easy since student. I'm liking. Yeah, well, at some point you have to learn how to do your own taxes. I actually, yeah, I should learn because I know the numbers are not that hard. But statistics and things like that, it's up there, it's up there. It's not even like hard numbers, it's just knowing what to do. How do I... How? Crap. These are such cool level designs too. Hold on. How do you level design a procedurally generated thing? Well, I mean, of course, they're curated, but still. You're gonna sign up for uni? You haven't yet? I'm lagging. Let's just go for it. Oh, there it is. Okay. Crap. Crap. Yeah, Tyler, you're doing a lot. Like, a lot of real big boy stuff. If you want to go to school, yeah. I did it. What are you going to study? Or what would you want to study? Electrical engineering as a major. Crap. The more for going just to learn and be first family to go. Yeah, huh. I'm technically I'm first generation as well. And with that, I would fail to... Hold on, I would fail that class. He's too cute. Huh? Wait, what? What are you talking about? So I'm gonna plant, maybe to compound. What are you... Hold on, let me look that. Let me look at... What are you saying? What are you saying? You guys are too much. Nepenthes, please stop teasing the math boy. This is unfair. And you guys too. You're egging her on. You guys are egging each other on. Do it. Okay, how do I get around this level? I gotta go on these like lips tower bits right here. Shit. Okay. Let me see. Am I stuck? Okay, so I'll make this my last level because I am very hungry. Oh, maybe I can just go around. Yes. Okay, where am I going? Right there. You see that? I'm stuck. I'm stuck. crap. Okay. Let me take a look at who else is here. Who can I raid right after this? Can you guys check to see if there's anybody interesting we can go bother? Oh, wait. Crap, I'm already too low. So why am I lagging? Let's see. I should not be more than 10 tries away from getting this. He died again. Crap. Okay, yeah, so it's supposed to be getting caught in the middle of these. Genie art, and she isn't edutainment. No, that's fine. I'm honestly, I'm down to just bother anybody, as long as, you know, they're cool and they don't mind, you know, just hanging out, I guess. Okay. Hold on. Scaffolding. Okay, and also, why am I, like, actually so lucky? Okay. She did an education collab with you, too. Did she? Well, what'd you guys cover? Oh yeah, my tummy's giving me the rumblies. It's okay. Self-digestion is good. Inviting me to inviting non-STEM people when asked what topic they know about. Yeah, no, it's always good to check what other people are doing, even if they're not STEM, even if they just do their own thing. Let's see, I bothered a few people. Dang, this is not crunchy frames. Yeah, maybe I can ask them, what's your favorite number? I always like starting that because people usually don't. They usually do. Normal people have a favorite number. But you ask like a scientist for some reason, you ask them, what's your favorite number? They're like, they don't have an answer. I think I asked, Kim what her favorite number was, and it was something related to space stuff. -8. Why that? Okay. I need to get this level. Crap. Okay. Favorite number is infinity. Infinity's not a number. Infinity's not a number. Actually. So if you're talking about infinity, it's actually not a number. It's a concept. Infinity plus 1. it's like when you're a kid and you're counting. Oh, I can think of the biggest number ever. Infinity plus 1. Well, the next one is Aleph. Aleph 0. Aleph null. Then the next one is Aleph 1. Get wrecked, nerd. Like the concept of infinity a lot. Yep. Start counting your first infinities. Start counting your countable infinities, and then next thing you're gonna do is you're gonna count your uncountable infinities. Okay. Next task: reach infinity. It's funny that doesn't know what we're talking about. The whole point of an aleph is an infinity. It's a level of infinity. So the first level of infinity is Aleph null. Aleph null is the countable numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8. And anything that you can pair 1 to 1. So as long as you can start and find the next one, then you can, that's considered Aleph null infinity. But stuff like real numbers, like square root of 2 or pi and stuff like that, they're irrational, and technically you can't even count them, right? Because let's say 0, and you start with 0, 0, 0, 0, 0, 0.0000000, and then ideally there would be a 1 to get to the next real number, but you don't go there because you can always add a 0 between it, which makes it an irrational number, which means that you can't even count the next number. So to quantify that, that is the next Aleph space. That is going to be Aleph 1. So my namesake is to say Aleph mu, because mu usually means measure and stuff like that. Ties in with measure theory. I don't like measuring probabilities, but I do like the Greek word mu, Greek letter mu, because it sounds, at least here in the West, we say mew like a kitty cat. Moo. It's a 𝖈𝖗𝖊𝖉𝖎𝖙𝖘. I'm gonna send you to Brazil. No explanation there. You're just going to Brazil. Keep that up. Damn it. Okay, I got an ad in 40 seconds. After ad break, I'm gonna probably wrap it up because I need to. I'm still hungry, and I don't work tomorrow. I gotta make my graphic for the schedule. What time? I'm getting pretty bad at keeping up pace with scheduling, so I will probably actually do tomorrow's stream whenever I want. Probably afternoon. I want to sleep in. Kitties are cute. Kitties are in fact cute. There's a bunch of cats that just started spawning in my neighborhood. One of the cats there's like 4 different cats that are pregnant in our neighborhood, and one of them had already gave birth to her kittens. So now we have her in a little box. We apparently snatched up her kitties. This was when I was away last week, so like everyone they saw the cats, and they started touching them and stuff like that. Man, I'm extra, thank you. So all the cats, I can grab them, I can play them around. I'm gonna play with them, but they're like literally like weeks old, and that's just one of the kitties, babies. How do you do this fucking level? Okay. Look at Brazil. Shit. Okay. I'm getting sick of this level. It's been 41 minutes. I do want food. I'm not hungry. Oh yeah, huh? Thank you, A. Okay, see, look, that's the thing. If I settle in those spots, it's exactly big enough that I can get stuck. See, that's why you go to college. You're the one with the real smart ideas. Okay, hold on. I need to get on those, like, orange pillar rail things. Okay, here I can settle just for a second. Hold on. But that's also one of these rail things. Okay, I gotta make sure to not get... Okay. You're only good at games. Well, better than me. I'd just do math. And even that I've been bad at recently, so. Oh, I have let me talk about this then. I want to do an emote. I want to do not an emote, a redeem. I want to do a redeem where basically you guys can just force me to do a random math problem. There's a bunch of like random math problem generators, so we can implement something in that capacity where we can you know, I'll just show something really quickly, just do it and then done. That'll help me with my retention, that'll help me with my studying. And then variety also is good because you guys can like see different kinds of things. Come on. Okay, that's it. Last try. So redeem to have you do A's homework. I could, I guess. Like, maybe I could do submissions. Do a submitted homework assignment. All right, that's it. That's one more time. One more time. Maybe it'll depend on task. So like maybe it could be like redeem a geometry question or a redeem a you know, calculus question. Maybe a physics one, and then some of them are enough that you could just fib the numbers a bit. Others you can yeah, they're a little more involved and you got to make sure the math works out. So I'm not sure if I'm gonna use like an AI like generation tool. I mean, honestly, AI is really good at generating math problems. I'm not gonna lie, it is actually really good. I use that for self-study a lot. But I obviously people have different attitudes about AI stuff. But I mean, honestly, I don't care. Botanical few. Is that true? I don't know if anybody has used it yet. Wait, what? AI's been carrying you. Yeah. Well, here's the thing, right? You obviously don't want to just depend on it for everything. So what you use it for is looking for resources, looking for example questions, break down something for me, because I need a little help understanding some stuff, right? Everyone knows how to do that bit, right? At least they should right now. Come on. 50% of my test because instead of 0 because of AI. What? Instead of 0. Why? AI is lame? Yeah, well, depends on what. Like, probably looking for credible sources. I know what Z Nap, you didn't you do the thing with Z the other day with looking for credible sources on AI and stuff like that? Or was that with someone else? I know Z did something recently. How is this stuck? Collision detection, my butt. A as a tool or as a teaching aid. Oh, it was 𝖈𝖊𝖉𝖎𝖙𝖘 and Z. Z? I'm gonna jump. You need help with proofs. Finally understood how to sort of right one and banging my head against the AI wall. That forced me to start writing like that. Yeah, it's wrong. Hold on. It's wrong. I've been to New Zealand before. Hold on. I did some research out there. Out there they keep saying Z. You know, welcome to the NZ. You know, Kiora, something something advertisements, right? And they would see like Kiora, look up, you know, something something grocery store .nz, and then they would do that because they're Kiwis. Did I say I'm hungry? I'm still hungry. I say it as I'm looking around. Tyler's making fun of Canadians. He doesn't like Canadian spelling. Tyler doesn't like Canadians. You heard it here first. Yeah. North Montanians. North Montanians. What do you call a person from Montana? Montanian? I know like Minnesotan is Minnesotan. American. That's right. We believe in the red, white, and blue out here. We just say that they're American, ain't that right? Yeehaw. Should the second soda enter the A study? Duh. Well, hold on. What kind of soda? Don't tell me it's a Coke. Everyone knows Pepsi is better. So when they say, oh, can I get a Coke? Is Pepsi okay? Yes. Pepsi is better, yeah. My university had nothing but Pepsi. It was Pepsi branded. So all Pepsi products and stuff like that. One of the drinks they actually had was called a Kickstart. It was like a Mountain Dew Kickstart. That was my drug. That was what I had for my laboratory assignments for computer science. There was like a vending machine right down the hall. I would go there like several times. It was like $3 or something. Nothing crazy. Spicy. Solar power. It means ice caps for you. Interesting. I'm learning so much about Canadian cuisine. How many maple syrups to moose tokens are those? This is a slow level. Do I have to just be slow? 3? Very good. Okay. Fuck! Okay, that's it. That's it. We're gonna wrap up right now. I'm eepy. I'm hungry. I'm gonna go drive and get some food, and I'm done. So let's go ahead and wrap up tonight. Let's see who we can bother, and I can throw you guys at them. I know, even if you don't want to stay up. Let's see who's online. Let's see. Soy Milk is on, unless she just finished. Soy's on. Mantis on. Let's see, who else can I bother? Oh, wait, hold on. You said Genie Art, right? I do not know Genie Art, but I will. You know what? Yeah, why not? So let's go ahead and do that. We'll go bother Genie Art. Let's see. Yeah, do your homework. Okay, let me see. Raid chat. Alright, guys. I will start setting things up right now for that. Okay. Now, on my end, usually it's like the laggiest thing ever. Because, of course, it has to be. I'm going to upgrade my stuff in the future soon. So, let's go ahead and... Should I knock first? No, we're just going to raid. Screw it. What is the raid message? Oh, shoot. What? I haven't done any raid messages, like, at all. I have no idea what to, like, say. So, what is something... something funny. Shoot. Fractal something. Fractals. Give me your jeans. That's cringe. That's cringe. Like peak cringe. I'm gonna time you out. No. Where's the raid message? What can we say? I don't know anything good. Let's see. And also let me lower this a bit. Yeah, let me just quit the game real quick. Okay, yeah, that's fine. Yeah, obligatory math is cool at the end of it too. Why not? Yeah, we'll just do this. We'll just do this. Yeah. It almost seems like a bot. I'm not gonna lie. It almost seems like we're like a bot or something stupid. All right, let's go ahead and do that. We'll just say insert raid message because I'm very creative. Alrighty, guys. You have a good night. Catch you later. Let's get started right now. You guys are ready to go. Have a good night. Bye-bye. Bye-bye. Copy the raid message. Insert raid message. Okay. Bye-bye. 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 Good night.